பண்ணிட்டேன் சார். வீடியோ ஆன் பண்ணலையா? என்னோட இதா தெரியுதா, ஐகானா தெரியுதா? இது தெரியுது. நான் ஆதிக்கா கொஞ்சம் லேட்டாக சொல்றேன். கரெக்டா இருக்கியா?
தெரியாது.
கொடுத்துருவாங்க.
Good morning.
Good morning, ma'am.
Good morning.
வேண்டாம்னு நினைக்கிறேன். மியூசிக் ப்ளே பண்ண வீடியோவே காணும். Everything is okay, Vasu. Sir, okay, ma?
Good morning. Good morning. Okay. Hello. Good morning.
Good morning, sir.
Good morning. Good morning.
Good morning, sir.
Good morning, sir.
Good morning. Good morning. Good morning. Sir Kumar sir, good morning.
Sir, good morning. Good morning.
Good morning. Good morning. Welcome.
Music ekdam. Antarina.
Good morning. Mic on பண்ணிடுங்க சார்.
Good morning. Good morning. மைக் ஆஃப் பண்ணி வச்சா ஆன் பண்ண மறந்து போயிருது.
Video ekdam.
Sir, good morning. Sir, welcome. Good morning, sir.
Sir, good morning.
Sir, Tamil Chulu, sir. Good morning. Welcome. அந்த இன்விடேஷனும் ப்ரோக்ராம் லிஸ்டும் போட்டு விடுங்க.
சார் எஸ் சார்.
ஓகே, அப்படி இருக்கட்டும்.
One minute, shall I try my presentation?
Okay, sir. Okay, sir.
Just
welcome,
one.
Sir. Welcome. Okay, sir. Okay, sir. Thank you.
Sir, just a minute, sir.
Yeah. Please.
Sir, just a minute, sir.
Doesn't matter.
Sir, now you can try, sir. Dr. KB, you stop sharing the screen. Dr. KB, please you stop.
Sir.
You please
Okay,
stop sharing.
Okay, sir. Okay. Okay, sir.
Okay. Sir, now you can try, sir. It is visible, sir. PPT is visible.
We are practicing on so many platforms. After a gap, the menu of one platform is getting forgotten.
Yes, sir. Yes.
Daily ஒரு வேற ஏதாவது பிளாட்ஃபார்ம் போயிட்டு வரும்பொழுது அந்த மெனு மறந்து
இது மறந்து போயிடும். ஆமா சார், ஆமா.
இது இப்ப நீங்க இன்னைக்கு லைசன்ஸ் வாங்கிருக்கீங்களா? இல்ல இது கூகுள்ல எப்படி மேனேஜ் பண்றீங்க இன்னைக்கு?
சார் இது ஃப்ரீ வெர்ஷன், ஃப்ரீ ட்ரையல் தான் சார்.
டியூரேஷன் ரெஸ்ட்ரிக்ஷன் இருக்குல்ல? இல்லையோ?
டியூரேஷன் இப்ப ரெஸ்ட்ரிக்ஷன் எடுத்துட்டான் சார், அன்ரெஸ்ட்ரிக்டட்.
எடுத்துட்டானா? சரி.
ஆமா, ரெக்கார்ட் மட்டும் பண்ண முடியாது சார்.
ரெக்கார்ட் மட்டும் பண்ண முடியாது.
ரெக்கார்ட் பண்ண முடியாது. நாங்க ஸ்கிரீன்ஷாட் எடுத்துக்கிறோம். எல்லாரையும் கேமரா ஆன் பண்ண சொல்லி முக்கியமான டைம்ல.
அப்ப அந்த 40 நிமிஷம்ங்கிறது அதை எடுத்துட்டான்.
அது எடுத்துட்டான் சார்.
அது எடுத்துட்டான்.
ஆமா.
இப்ப அதனால பல பேர் என்ன பண்றாங்க, லோக்கல் ஆப் டெவலப் பண்ண ஆரம்பிச்சிட்டாங்க. ஒரு 2 நாளைக்கு முன்னாடி ஈரான்ல ஒரு கான்ஃபரன்ஸ் என்டையர்லி டிஃபரெண்டா இருக்கு, எல்லாம் வெவ்வேறா இருக்கு. சரி. அது அவங்களே டெவலப் பண்ணிக்கிறாங்க.
எல்லாமே படிச்சிடுறாங்க, நிறைய படிச்சிடுறாங்க அவங்களே.
இப்போ
அது நல்லா இருக்கா சார்? இதே மாதிரி நல்ல யூசர் ஃப்ரெண்ட்லியா இருக்கா?
எல்லாமே ஒரே பிளாட்ஃபார்ம் தாங்க. பேக் எண்ட்ல ஏதாவது ஒரு இதே இதுதான் வச்சிருக்காங்க, ஒன்றும் பெரிய பிரச்சனை இல்ல.
டெக்னிக் சேம் தான்.
இந்த மெனு வெவ்வேறா இருக்கிறதுனால ஐகான் எதுன்னு புரிய மாட்டேங்குது.
ஓ சரி.
எனக்கு தெரிஞ்சு ஜூம் தான் ரொம்ப கம்ஃபர்டபிளா இருக்கு.
ஜூம் நல்லா இருக்கு, கிளாரிட்டியும் நல்லா இருக்கு சார்.
நல்லா இருக்கு.
ஆனா காஸ்ட்லியா
நல்லா
இருக்கு.
இருக்கு. வெப்எக்ஸ் வந்து சாஃப்ட்வேர் லைசென்ஸ் இல்லாம ரொம்ப காஸ்ட்லியா இருக்கு.
ஆமா சார்.
வெப்எக்ஸ் நல்லா இருக்கு.
அப்புறம் ஸ்ட்ரீம்யார்ட்னு ஒன்னு சொல்றாங்க சார். ஸ்ட்ரீம்யார்ட்ல நாங்க போனா அது வந்து ஆமா ஸ்டுடியோ மாதிரி தான் இருக்கு. only 6 members can accommodate. ஆமா, மீதி எல்லாரும் யூடியூப்ல லிங்க் பண்ண வேண்டியது இருக்கு. So we are also giving YouTube link sir after 100. KB யூடியூப் லிங்க் வந்துருச்சா டாக்டர் KB?
சார் ஆமா சார், ரிசீவ் பண்ணிட்டோம். உங்களுக்கு நான் வாட்ஸ்அப் பண்ணிருக்கோம் சார். எல்லாருக்குமே குரூப்லயே வாட்ஸ்அப் பண்ணிருக்கோம் சார்.
ஓகே.
யூடியூப் லிங்க் போஸ்ட் பண்ணியாச்சு.
ரைட், வெரி குட்.
சார் நான் ப்ரோக்ராம் ஷெட்யூல் டிஸ்ப்ளே பண்ணலாமா சார்?
பண்ணுங்க. ப்ரோக்ராம் ஷெட்யூல் போட்டு விடுங்க.
ஓகே சார்.
Sir, good morning, sir.
Good morning, KS.
Good morning, sir.
Good morning, sir.
KS வீட்ல இருந்தா டிபார்ட்மெண்ட்ல இருந்தா?
வீட்ல தான் சார் இருக்கேன்.
வீட்ல.
கலா மேடமும் ஏதோ ஒரு கான்ஃபரன்ஸ் போல, அதனால நான் வீட்ல இருந்து அட்டெண்ட் பண்ண போறேன் பாருங்க.
சார் ஆசிர் சார் உள்ள ஜாயின் பண்ணிட்டாங்க சார்.
ஓகே.
ஓகே. ஆசிர் சார் குட் மார்னிங்.
Yes. Asir, good morning. Asir, unmute your mic.
அங்க போறது சார். Can you hear me now?
Yes. Just now we are hearing, but voice is very low. Asir.
Good morning, sir. Good morning, sir.
Good morning. Welcome.
Okay, sir. Leave.
இல்ல வர்க்கிங் டே தான்.
கான்ஃபரன்ஸ்னா அப்புறம் என்னப்பா நீ வேற கேள்வி. நெட் ஃபெசிலிட்டி எங்க இருக்கோ அதான் வர்க்கிங் பிளேஸ்.
Work from home.
I hope secretary has joined, isn't it?
I will verify, sir.
ஒரு செக்ரட்டரி தானே இப்போ ஜாயின் பண்ணிட்டு லெஃப்ட் ஆச்சு.
எஸ் சார் ஜெயக்குமார் சார்.
Sir Magendra sir, good morning.
Mic is unmute, sir.
Sir, good morning.
Sir, principal sir, please unmute your mic.
Principal sir, please unmute your mic. Good morning, sir. Good morning. Welcome. Sister Kulandai Teres, good morning. Welcome.
Good morning, sir. Good morning, sir. Good morning.
Good morning. Good morning. Good morning.
அவருக்கு ஒரு ஃபோன் பண்ணுங்க
சரி சார்.
பிரின்சிபல்.
ஓகே ஓகே. கேபி, டாக்டர் கேபி.
சார் நான் கால் பண்றேன் சார். சாருக்கு கால் பண்றேன் சார்.
பண்ணிட்டு
சார் குட் மார்னிங். சார் குட் மார்னிங்.
குட் மார்னிங்
சார். குட் மார்னிங்.
சார் குட் மார்னிங் சார்.
அனைவருக்கும் வணக்கம்.
வணக்கம் வணக்கம்
வணக்கம் வணக்கம் சார். ஜெயக்குமார் சார் ஜாயின் பண்ணல இல்ல இன்னும் பண்ணிட்டாங்களா?
சார் ஜாயின் பண்ணாங்க.
லெஃப்ட் ஆனாரே.
அவங்க பாக்கியராஜ் மேடம் பேசுறாங்க கேட்கலையே. பேசுறாங்கல்ல?
எஸ் சார்.
He is audible.
He is audible.
Sir, I am audible, sir.
Yeah, you
Yes,
are
yes,
very
sir.
much audible.
Yes sir. Yes sir.
You are audible, sir.
Sir, பசங்க சார் கேக்குது ஆடியபிள் தானா?
எஸ் சார். எஸ் சார்.
சார் நீங்க பேசுறது கேக்குது. கேக்குது. நாங்க பேசுறது கேக்குதா?
எஸ் சார். எஸ் சார்.
இல்ல இல்ல
மகேந்திரன் சார்
சார் மகேந்திரன் சார்.
எஸ் சார்.
அவர்ட்ட ஏதோ ஆடியோ ப்ராப்ளம் இருக்கு.
எஸ் சார். எஸ்.
Please
டாக்டர் கேபி செக்ரட்டரிக்கு ஒரு ஃபோன் பண்ணிரலாம்.
You are audible.
Okay.
Thank you. Bhagirathi madam, please check it. He was not able to hear you.
Yes sir. My voice is not audible or not,
Yeah,
sir?
audible. Clear.
Please ascertain the secretary.
Okay sir. Okay. Secretary sir. Yes sir. Yes.
டாக்டர் கேபி.
சார் கால் பண்ணிட்டு இருக்கேன் சார். செக்ரட்டரி சார்.
ஓகே ஓகே. ஓகே ஓகே ஓகே. கேளுங்க.
ஓகே சார்.
கும்பிட மட்டும் போட்டு போ.
சார் வணக்கம் சார்.
வணக்கம் வணக்கம் மேடம். வணக்கம். மகேந்திரன் சார்.
எல்லி மேடம் வந்திருக்காங்க. குட் மார்னிங்.
ஆமா. குட் மார்னிங்.
சார் வணக்கம்.
மேடம் வணக்கம்.
வணக்கம் சார்.
வணக்கம் மேடம்.
சார் செக்ரட்டரி சார் லைன்ல தான் சார் இருக்காங்க.
அப்படியா?
ஆமா சார். ஆமா.
கிரிட்ல I think
பேசிட்டீங்கல்ல சார் உள்ள இருக்கேன்னு சொன்னாங்களா?
எஸ் சார். எஸ் சார். சார் நேம் உள்ள டிஸ்ப்ளேல தான் சார் இருக்கு.
ஓகே.
ஜெயக்குமார் ஜெய்கேன் போட்டிருக்கு. சார் செக்ரட்டரி சார் ஜெயக்குமார் சார் குட் மார்னிங். வெல்கம்.
சார் லைன் போன்ல லைன்ல தான் இருக்கேன்னு சொன்னாங்க சார்.
அப்படியா?
அவர் வேற பேர்ல இருக்காரா கேளுங்க.
ஆமா, என்ன பேர்ல இருக்காங்க?
முதல்ல இருந்தார், லைன்ல இருந்தார். ஜெயக்குமார் ஜேகேன்னு ஒரு ஐடியில இருந்தார்.
ஆமா சார். அந்த ஐடியில தான் சார்.
இப்ப வேற ஐடியான்னு கேளுங்க. அந்த ஐடி ஆக்டிவ் இல்ல. நீங்க பார்ட்டிசிபென்ட்ஸ்ல பாத்தீங்கன்னா தெரியும். ஜேல மொத்தம் 3 பேர் தான் இருக்காங்க. I think he might be in some other ID or you can ask him to put on his video so that we can or you can speak a while so that he will come to the main grid.
சார் திரும்பவும் சாருக்கு கால் பண்றேன் சார். வெரிஃபை பண்ணிட்டு சொல்றேன்.
பண்ணுங்க.
He is not in the time.
பண்ணுங்க
பண்ணுங்க, ட்ரை பண்ணுங்க, ஒன்றும் அவசரம் இல்லை. அவர் வேற ஐடியில இருந்தாதான் உண்டு.
டாக்டர் கேபி
சார் சார் எங்க சார் வந்து செக்ரட்டரி சார்ட்ட பேசிட்டு இருக்காங்க சார். மைக் ஆன் பண்ண சொல்றாங்க சார். அவங்க என்ன ஐடியில இருக்காங்கன்னு பாக்குறதுக்காக.
ரைட். ஓகே.
ஒரு மைக் ஆன் பண்ணிட்டு கொஞ்சம் பேசினாருன்னா ஆட்டோமேட்டிக்கா விசிபிளுக்கு வந்துருவாரு ஆக்டிவ் ஸ்பீக்கர்ல.
அப்படிதான் சார் சொல்லி இருக்கிறோம்.
ஓகே.
சார் ஒரு தடவை சார் உள்ள வந்துட்டு வெளியில லெஃப்ட் ஆனாங்களாம் சார். திரும்ப உள்ள ஜாயின் பண்ண முடியலங்கறாங்க. நான் வெரிஃபை பண்றேன் சார். இப்போ என்ன சொல்லிட்டு
நீங்க யாராவது ரெஸ்ட்ரிக்ஷன் இருக்கா அலௌடுக்கு? இல்ல அவரை வந்து வெளியில கம்ப்ளீட்டா போயிட்டு மறுபடியும் லிங்க் பண்ண சொல்லுங்க. லிங்கை கிளிக் பண்ண.
ஓகே சார். ஓகே.
ஆஸ்க் டு ஜாயின் வரும்போது
ரீஜாயின் பண்ணா சொல்லுங்க. ரீஜாயின் பண்ண சொல்லுங்க சார்.
ரீஜாயின் பண்ண சொல்லுங்க. மறுபடியும் கம்ப்ளீட்டா வெளியில போயிட்டு உள்ள வர சொல்லுங்க.
ஓகே சார். ஓகே.
He has joined now. Secretary has joined now. Please ask him to unmute his mic or someone plus admin. அவருடைய மைக் வந்து மியூட்ல இருக்கு.
ஓகே சார்.
நீங்க தான் அன்மியூட் பண்ண முடியும். எனக்கு அந்த ஃபெசிலிட்டி இல்ல. ஜேகே ஜெயக்குமார் ப்ளீஸ் நீங்க உங்க அட்மின்ல இருந்து அவருடைய மைக் அன்மியூட் பண்ண சொல்லுங்க.
சொல்றேன் சார்.
ப்ளீஸ்.
Sir, Secretary sir. Sir.
ஜெயக்குமார்
லெஃப்ட் ஆயிட்டாரு.
மறுபடியும் உள்ள வந்துருச்சு.
இல்ல அவரு ஐ ஹோப் அவர் ரெட் பட்டன் அழுத்திடுறாருன்னு நினைக்கிறேன். அந்த கடைசியில இருக்கிற நானும் சமயத்துல இந்த தப்ப பண்ணிட்டே இருப்பேன். நம்ம அந்த
ஓ.
லீவ் கால்
இப்ப மைக்
இருக்குங்களா,
ஆன் பண்ணியாச்சு.
அது வந்து மைக்
ஜெயக்குமார்
நினைச்சிட்டு
சார்
அதை பிரஸ் பண்ணிடுறோம்னு நினைக்கிறேன்.
இப்ப மைக்
லீவ்
ஆன்
கால்
பண்ணிருக்காங்க.
கடைசி பட்டனை மைக் பட்டன் வச்சுட்டு அதை
ஜெயக்குமார்
பிரஸ்
சார்
பண்ணிட்டா வெளியே போயிடும்.
சார் குட் மார்னிங். சார் குட் மார்னிங். செக்ரட்டரி சார் குட் மார்னிங்.
யூ ஆர் சார். யா
சார் குட் மார்னிங். ஜெயக்குமார் சார் குட் மார்னிங்.
நவ இஸ் ஆடிபிள். சார் குட் மார்னிங். நாங்க பேசுறது கேக்குதா? Please put on your camera.
Sir, Secretary, sir.
சார் கேமராவும் ஆன் பண்ணுங்க. கேமரா ஆன் பண்ணிட்டு நாங்க பேசுறது கேக்குதா? செக்ரட்டரி சார். Secretary sir, your mic is on. You can speak now. Are you able to hear us? He has some problem.
Sir, please speak in the mic. அவர் மொபைல்ல ஆன் ஆயிருக்காரா?
அப்படிதான் தெரியுது. மறுபடியும் லெஃப்ட்.
மொபைல்ல அவர் மொபைல்ல இந்த மெனு வந்து அவ்வளவு கிளியரா தெரியாதுல்ல கீழே.
ஆமா ஆப்ஷன்
பேசுனேன் சார். அவங்க எல்லாமே நான் வீடியோ ஆடியோ எல்லாமே ஆன்ல தான் இருக்கு அப்படின்னு சொல்றாங்க சார். உங்க சைடு ப்ராப்ளமான்னு கேக்குறாங்க சார். திரும்ப ஜாயின் பண்ணிட்டாங்க சார்.
ஜாயின் பண்ணிட்டாங்க சார். ஜெயக்குமார் சார் மைக் ஆன் பண்ணுங்க, கேமரா ஆன் பண்ணுங்க. Your mic is in mute mode.
சார் செக்ரட்டரி சார் ஜாயின் பண்ணிட்டீங்களா? செக்ரட்டரி சார்
ஜாயின் பண்ணிருக்காங்க. பட் அவங்க மைக் ஒர்க் ஆக மாட்டேங்குது, வீடியோவும் ஒர்க் ஆக மாட்டேங்குது. அவங்க தான் ஆன் பண்ணணும்.
சார் எங்க சார் 2 நிமிஷத்துல கொண்டு போய் கொடுத்துறேன்.
நீங்க அட்மின்ல இருந்து ஆன் பண்ண முடியாதா?
அந்த ஆப்ஷன் இல்ல சார். ஆப்ஷன்
அட்மின்ல இருந்து ஆன் பண்ண சொல்லுங்க.
ஓகே சார். ஓகே.
யார் அட்மினோ அவங்க பண்ணலாம்.
ஓகே சார். ஓகே.
யாராவது ஒருத்தர் கோ ஹோஸ்ட் வச்சுக்கோங்க. ஏன்னா ஒருத்தரே மேனேஜ் பண்ண முடியாது சம்டைம்ஸ்.
இன்னொரு ஸ்டாஃப் மெம்பர் தான் சார் கோ ஹோஸ்டா இருக்காங்க.
அந்த 2 பேர்ல ஹோஸ்டோ அல்லது கோ ஹோஸ்டோ யாராவது ஒருத்தர் அவருடைய மைக் அன்மியூட் பண்ண சொல்லுங்க.
ஓகே சார். சார் நம்ம ஸ்டார்ட் பண்ணலாமா? சார் இப்ப 2 மினிட்ஸ்ல கொண்டு போய் கொடுத்துருவாங்க சார் வீட்ல.
பிரின்சிபல் சார், shall we start?
Please go ahead, sir.
செந்தூர தேவி.
மேம் வீடியோ ஆன் பண்ணணுமா?
ஆன் பண்ணுங்க.
ஓகே மேம்.
ஓகே, ப்ரோசீட் பண்ணலாம்.
Good morning everyone. I welcome one and all gathered here for this wonderful session of our prestigious institution. A day without prayer is a day without blessing. Now I welcome our girls to sing the prayer song.
அறிவும் ஞானமும் தந்திடும் அனைத்தும் ஆளும் தெய்வனே. அறிவும் ஞானம் அனைத்தும் ஆளும் என்னையும் ஒரு உயிரென என்னையும் ஒரு உயிரென கடலும் காணும் கருணை வாழ்வும் தந்தாய் பலமும்.
ஹலோ
கேக்குது சார், கேக்குது. Now you are audible.
குட் மார்னிங்.
Good morning, good morning, sir. Good morning.
வீடியோ கட் பண்ணிக்கோங்க.
Thank you, girl, for starting this session with a shower of blessings. Taking further and to begin with the session, I, on behalf of everyone present here, heartily welcome our convener and the head of the department, Dr. S. Pasangili Pandian, Adityanar College, to deliver welcome address. Let me extend a warm welcome to you, sir.
Thank you. Respected Principal, Dr. D.S. Magendran, respected Secretary, Dr. S. Jayakumar, guest of honor, the chief guest, Dr. T. Tamilchelvam, the resource persons, Dr. Prabhu Natarajan, Dr. K. Selvakumar, and Dr. T. Azir. Faculty members of our department, the organizing secretary, Dr. K. Bhagirathi, faculty from our college and faculty members from various colleges, scholars, participants, and my dear students. A very good morning to all. Before welcome you all for this one-day international conference, it is my bound duty to thank few people present here who are behind this great event. First of all, I express my wholehearted thanks to the distinguished guest, Dr. T. Tamilchelvam, Dr. Prabhu Natarajan, Dr. K. Selvakumar, Dr. T. Asir, our principal, Dr. D.S. Magendran, and Secretary, Dr. S. Jayakumar. I express my sincere thanks to the organizing secretary, Dr. K. Bhagirathi, and his team, Mr. P. Selvan, Dr. S. Saranya, most importantly, Dr. Sivamurugan, husband of Dr. K. Bhagirathi. We hear that for every successful man, there is a woman behind. But here it is true in both ways. Every successful woman, there is a man. That is Dr. Sivamurugan, Assistant Professor of Economics of our college, for their tireless work and the effort they have put into in conducting this mega event. On day one itself, when we have planned to conduct this conference, they have started the work and continue till today and going to continue till the certificates are issued and publication is over. Really, I am very fortunate to have such dynamic persons as my colleague. No words to express their hard work. I congratulate Dr. K. Bhagirathi, the organizing secretary of the conference, and all staff members of our department. Coming back to welcome address, first of all, I am happy to welcome our principal, Dr. D.S. Magendran, who always encourages us to conduct programs like this and helps us in many ways. On behalf of the organizing committee, I welcome you, sir. Next, I would like to welcome our secretary, Dr. S. Jayakumar, who always guides us and motivates us by his words and action. Welcome you, sir. I am very much privileged to welcome the great scholars as resource person for this conference. I extend my warm welcome to my guide and the chief guest of this conference, Dr. Tamilchelvam, who is the inspiration for me and for most of our mathematicians in academic activities. Almost all mathematics people across the globe know him. A great scholar and a best administrator too. which is a rare phenomenon. On behalf of the organizing committee and on my own behalf, I wholeheartedly welcome you, sir. Welcome, sir. I would like to welcome Dr. Prabhu Nararajan from Sultanate of Oman. When I contacted him over phone, he immediately accepted my invitation. Also, he has given his full support in conducting this conference. Actually, we have planned to conduct this program in December 2021, and at that time itself, I got his acceptance. Welcome you, sir. I am happy to welcome Dr. K. Selvakumar, Professor of Mathematics, MSU, who also helped us in many ways. Also, he has accepted to chair the paper presentation session. Welcome you, sir. I would like to welcome Dr. T. Asir, Assistant Professor and Head in Charge, Department of Mathematics, MKU, a young mathematician with many awards, who helped us in giving some suggestions and accepted to be a chairperson for the presentation. Welcome you, Asir, sir. Also, I am very much happy to welcome the chairpersons for the presentation sessions, Dr. Pius Missier, former principal, Don Bosco College, and former associate professor of mathematics, UOC College. Dr. Jaypalan Kennedy, head and associate professor of mathematics, Mergasius College, Nazareth. Dr. Palani Madam, head and associate professor, Department of Mathematics, APC College. Dr. Premalata, head and associate professor of mathematics, Rani Anna College, Tirunelveli. Dr. Meena, associate professor of mathematics, MD Dikindu College, Tirunelveli. Welcome you all. I extend my warm welcome to faculty members of our department, heads and faculty members of our college, and various colleges, scholars, and students. Welcome you all. I am very happy to inform you that we have received 80 papers for presentation, and totally 180 participants have registered for this event. We are very happy for such a huge response in short span of time. Also, I am happy to inform you that the e-proceedings of this conference is almost ready, and as soon as we get the ISBN number, we will send it to your email ID. I hope you are going to enjoy the mind-blowing sessions to come. Wish you all the best. Thank you. Thank you, one and all.
Thank you, sir, for your warm welcome. Next, I welcome such an inspiring personality, our principal, sir, Dr. D.S. Mahendran, Principal, Adityanar College. You are always a person who is ready to travel extra miles. May I now request our principal to deliver presidential address.
Good morning to all. So I am audible, sir.
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir, you are audible.
Respected Secretary Dr. Jaykumar, distinguished guest of this morning, Emeritus Professor Tamil Chelvan, and the great administrator of Manoranjan Sundarana University, Tirunelveli. Dear Head of the Department of Mathematics and Research Center and convener of this program, Dr. Pasingli Pandian, organizing secretary of this international conference, Dr. Bhagirathi, and the young scientists of our college, and dear faculty members of Department of Mathematics, and dear participants, dear chairpersons, dear resource persons, Professor Selvakumar from Manoranjan Sundarana University, Professor Asir from Madurai Kamaraj University, and others from various universities. Very good morning to all. It's a great pleasure for me to deliver the presidential address in this international conference, e-conference, organized by the Department of Mathematics and Research Center of our college. Really, I would like to say 3 words about the Department of Mathematics. The Department of Mathematics is known for research from even in 1985. From the south, I would like to say that in 1990s, only 2 colleges are having MPhil mathematics in Madurai Kamaraj University at that time. Our college is one of the colleges we are having MPhil. Also, very senior faculty members, Professor Alphonse Ajendran is known for the group rings and all, and Professor Sankavil was there. Professor Ramachandran is there. So many faculty members and very good researchers they work in our college in the department of mathematics. So the same trend is followed by the other faculty members, other head of departments. So Professor Velrajan was there, and now at present Professor Pasingli Pandit is there, who is organizing this wonderful webinar or wonderful international conference. Really, this conference will be useful to the researchers in the field of mathematics, especially I think in the field of topology and all. And the organizing secretary, Dr. Bhagirathi, at this at her young age itself, she has produced so many research scholars. And also she has applied for the projects and all, always used to publishing papers, interest in showing and publishing papers and all. So like that, and other faculty members, Dr. Nityananda Jyoti, Dr. Shanbha Devi, Dr. Jayanti, and other faculty members, they are also contributing their level best for the development of the department and also for the development of the college. So organizing a program is not an easy thing. So it is not an easy work. So it should be contributed by the many faculty members. All the department faculty members, they contributed their contribution in some other ways to the successful conduct of this international conference. So I take this opportunity to appreciate and congratulate Dr. Pasingli Pandian and his team for organizing a wonderful program for the welfare of the institution. So in this pandemic situation, so I request many departments to organize this program, and the mathematics department has come out successfully, and other departments, they are also planning for the international or national conferences in the coming days. So this Aitana College, generally from the inception 1965, founded by our founder Sipa Adityanath, to develop the localities in the south, especially the southern region. We don't have any colleges. The government colleges are on northern side. So if the students, they would like to go for higher study, then they have to either go to Tirunelveli or Tuticorin. It's very difficult for the student south area. So in order to educate the people in the southern area, our Aitana College was established in the year 1965. And our founder president, Padma Shri Dr. Sivandi Aitan, he developed this college, and the same trend is followed by his son, the current chairman, Sri Balasubramanian Aditya. Regarding our colleges, our college, we are having 5 research departments. Very recently, with a small gap, the Department of Mathematics, it also became the research department. So this is the first program organized by the mathematics department after renewing the mathematics department as the research department. Hope that they will organize so many programs in the coming years. I heard that around 80 papers, they have received 80 papers, and also they have planned to publish the e-proceedings with ISBN number. It is a great thing. So the hard work done by the Dr. Bhagirathi and your partner, Professor Sivamurugan. So once again, I congratulate the Department of Mathematics and all the organizers for organizing this program. Wish you all the best. Thank you.
Thank you, sir, for your beautiful words. Next, I welcome our Secretary, sir, Dr. S. Jayakumar, to deliver felicitation address.
Secretary, sir.
பாண்டியன் கேக்குதா? ஹலோ.
Yes,
Hello.
yes, you are audible.
கேக்குது சார், கேக்குது.
Please start. Yes, you are audible.
ஹலோ
கேக்குது சார், கேக்குது சார், கேக்குது.
அம்மா நீங்க பேசுங்க. யா
மார்னிங்
குட் மார்னிங்.
கேட்கல. அனைவருக்கு இனிய காலை வணக்கம்.
சார் மைக் ஆஃப் பண்ணிட்டீங்க, மைக் ஆன் பண்ணிக்கோங்க.
நெட்வொர்க் இஷ்யூஸ் இருக்கும்னு நினைக்கிறேன் சார்.
எஸ் அங்க டவர் ப்ராப்ளமா இருக்கும், சரியா சிக்னல் கிடைக்கலன்னு நினைக்கிறேன்.
Then go for next agenda.
ஓகே சார். செந்தூர தேவி,
Sir.
Next event.
Okay, sir. May I now request Dr. K. Bakireddy, Assistant Professor of Mathematics, to introduce the chief guest.
I am very happy to welcome one and all present here. First of all, good morning to all our respected Secretary Dr. S. Jaykumar sir and enlightened Principal Dr. D.S. Mahindran sir. Honorable speakers Dr. T. Tamilselvam sir, Dr. Prabhu Natarajan sir, and Dr. Asif sir, and Dr. Selvakumar sir, and our beloved HOD Dr. S. Pasumli Pandian sir, and faculty members, research scholars, students from various institutions and our institutions. Very, very good morning. First, I would like to thank our management, secretary, principals, for giving me this opportunity to organize a one-day international virtual conference on current scenario in modern mathematics. I am very proud to introduce our speaker, Dr. T. Tamilselvam sir, Emeritus Professor, Department of Mathematics, Manonmaniyam Sundarnar University, Tirunelveli. He has completed his higher studies in Annamalai University, Chidambaram. His area of specializations are algebra, algebraic graph theory, and graphs from algebraic structures. He started his career as a lecturer in mathematics from government colleges from the period 87 to 1990, and promoted as a senior lecturer in Department of Mathematics from the period 90 to 97 at Gandhigram Rural University, Gandhigram. Then he moved to our Manonmaniyam Sundarnar University, Tirunelveli, designated as a reader from 97 to 2003 and professor from 2003 to now till date. Now serving as an emeritus professor in Department of Mathematics at Manonmaniyam Sundarnar University. Under his guidance, nearly 45 scholars completed their PhD degree. He has organized many workshops, conferences, and seminars. And he had given many informative talks, very, very useful informative talks in various refresher courses organized by HRTC in different universities. Until now, he has published around 120 research papers in national as well as international journals, and published 19 conference proceedings and 7 books also. And popularity of his research articles can easily observed by the citations and indexing in Google Scholar 565 and Scopus 237, Web of Sciences 210, and ResearchGate 367. And his publications reached the height index value in Google Scholar 30, Scopus 7, Web of Science 7, and ResearchGate 21.65. And he has successfully completed 4 individual projects, the amount rupees 44 lakhs, and in collaboration with the department as a coordinator, he received 3 projects under UGC SAP and DST FIST and NBHM worth of rupees 1.44 crores. And his significant contributions to the department are: first one is the Department of Mathematics got recognition from the following national agencies through proposals prepared and presented by our speaker, Dr. T. Tamilselvam sir. First one is the National Board of Higher Mathematics, NBHM, for special library grant from the year 1998. And second one is UGC SAP, Special Assistance Program from the year 2007, and DST FIST from 2012. And he has conducted many national conferences and workshops, motivated the students of the department to succeed the UGC NET and SET exams. And sir has served various positions in the university campus. He has received many awards and recognitions. Particularly, first one is the Tamil Nadu Senior Scientist Award from the year 2016, given by the Higher Education Department, Government of Tamil Nadu. And the second one is the Tamil Nadu Scientist Award, TANSA Award, in the year 2011, awarded by Tamil Nadu State Council and Council Science and Technology. And Lifetime Achievement Award in 2012 Group of Institutions, and Academic Excellence Award by MS University for the year 2009 to 10. And he has passed the All India Leadership Examinations of CSIR in the year 1989. And he has awarded the senior, first one is the Junior Research Fellowship on the basis of national level examinations conducted by the Council of Science and Industrial Research, CSIR, from the period 83 to 85, and the Senior Research Fellowship from the year 85 to 87. And he received the Ganapati Iyer Gold Medal and Professor V. Balaya Gold Medal for the first rank in MSc. And he has the life member of Indian Mathematical Society and Indian Mathematical Society, Indian Science Congress Association, and life member of Academy of Discrete Mathematics and Applications, member of American Mathematical Society. He has visited various countries like Taiwan, Dubai, Hungary, UAE, and Singapore for the purpose of invited talks. And he has the reviewer of many reputed journals. We are very lucky such a great personality person being a speaker. He is going to deliver the keynote address in our conference. I am taking this opportunity to extend my hearty thanks to you, sir, for accepting to take part in the keynote address and made this conference a successful one. Thank you so much, sir. With these words, now I invite Dr. Tamilselvam sir to deliver the keynote address. Thank you.
Good morning to one and all. Respected Secretary, Professor Jayakumar, respected Principal, Dr. Makendran, the Head of the Department of Mathematics, Dr. Pasangali Pondian, the Organizing Secretary of this International Conference, Dr. Bhagirathi, faculty members from Department of Mathematics and other institutions, as well as research scholars and participants. I thank for this opportunity, and I really thank the Organizing Secretary for the nice words, but still I feel that I should make myself still more to do. And this international conference on recent scenario in mathematics is well organized by the Department of Mathematics. As pointed out by the principal, this department is known for its excellence, academic excellence, right from 1980s. I happen to know Dr. Alphonse Rajendran from 1983, since he was doing research in Ramanujam Institute. And thereafter, I have been closely associated with almost all the people of this department, and it has got its name through its students. Just I would like to highlight what is the recent trend in mathematics. Just let me present my presentation. I hope it is visible.
Yes, sir.
Okay. Okay, if we take into the components of mathematics, these are the terms which have been used: definition, example, counterexample, something statement, maybe theorem, lemma, proposition, and methodology of proof, and so on and so forth. And these components give the tool for development of mathematical phenomena. And if you look into the nature of mathematical statements, it is non-temporal. It is not in the past tense or future tense. It is always in the present tense. And there is no attribution for anything. It reflects as it is what exists. Of course, you can note down that every statement will use only is, no, was, or shall, or will. And of course, every mathematical statement is devoid of emotional content. There is no emotional attachments being conveyed through statements in mathematics. It is a precise way of doing. And of course, if you look into the history of mathematics, the numbers were the initial concepts. Of course, number theory was the backbone of mathematics for a very long time. And later on, in 17th century or 18th century, the set theory has come into the picture. Ultimately, logic is taking place. Of course, if you look into the history and what are all important theorems, just I will give a very few and then I'll come to move on. The very first theorem in mathematics in the history is supposed to be Rayleigh's theorem, which talks about the geometry. If a triangle is inscribed in a circle, so that one of its sides goes through the center of that circle, that is, you are inscribing a triangle in the circle with diameter as one of its sides, then angle of the triangle that is opposite to the side is a right angle triangle. So this is known for every student, even in school days. This angle subtended by the diameter in the perimeter is always right angle triangle. Of course, this is discovered during 6th BC, and it is proved by a Greek mathematician, Thales. And this is supposed to be the oldest theorem in mathematics. And not only that, this is a theorem with rigorous proof. Of course, if you look into the history, in the ancient days, maybe 15th century or even before that, the people who are involved in mathematics were of the opinion that no proof should be given. Only statements must be stated, and the proof must be developed by the man who is reading the statement. Thereby, it is the way of inculcating the talent of mathematics among the people. Of course, in contrast to the customary, this is the first theorem which has been given the proof. Of course, the second one, or supposed to be the next one, is the very famous Pythagoras theorem. If A and B are the lengths of the two legs of a right angle triangle, and C is the length of the hypotenuse, then A square plus B square is C square. I appeal to the audience. It is the most well-known statement, and it is the belief that it was discovered by Pythagoras. It is not so. Even that was known to Babylonians and Chinese people about 100 years earlier. Sometime in 1707 BC, this is known to the people. And one of the beautiful facts about this theorem is there are 370 different proofs available for this one particular simple theorem. I appeal to the audience. Do you know any proof for the Pythagoras theorem? Have you come across proof in your life? I think nobody had the chance of learning the proof in their school curriculum, as well as in the college syllabus, it is not included. However, there are 370 proofs. Most of them depend upon the geometry. I will give a simple narration. Of course, all the proofs were published as a book by Elisha Scott Loomis in 1927. Even 100 years ago, this simple statement has got 370 different proofs. Okay, just I will give you. Take a square of side A plus B and split the square into 5 regions. One is right angle triangle, sorry, 4 right angle triangles and one inner square of side A. You draw yours. And one side is square C and the 4 right angle triangles with the sides A and B. So you cover the entire area of the larger square. Area of the larger outer square is A plus B whole square. Area of the inner square is C square. And the area of the 4 right angle triangles is half AB into 4AB. Therefore, this A square plus 2AB plus B square is equal to C square plus 2AB. 2AB gets cancelled. A square plus B square equal to C square. This is a very simplest proof for Pythagoras theorem. And Euclid's first theorem, if a prime number divides the product of 2 integers, then it must divide one of them. It is the property of a prime number. Prime number cannot be accommodated in 2 different products. So that is due to Euclid. And of course, as a consequential fact, every integer can be expressed as the product of distinct primes. That's the fundamental theorem of number theory. Of course, the very beautiful, another important statement in mathematics is there are infinitely many prime numbers. Someone asked how many prime numbers you have. It is infinitely many. And of course, the proof is very elegant. If you take, suppose in contrast, if you take P1, P2, Pk as k distinct primes, then consider the number product of P1, P2, Pk plus 1. It is also a prime number. And this is the number prime number which is different from all these things. So this construction tells you that if you know something k, the k plus 1 is known, inductively one can go for infinitely many. Of course, there are very different 6 proofs for this fact. You can see from the book of proofs. And it is using Euclid proof, Fermat numbers, Mersenne numbers, elementary calculus, topology, and a series of sum of primes. So this algebraic property even make use of the topology, and there is a proof. Please look into that. As I said, the fundamental theorem of arithmetic. Every integer can be expressed as the product of distinct primes in a unique way. And of course, it is my duty to mention that even now, the people are trying what is the largest prime. Even at this moment, the known largest prime is sometime in October 2021. It is 2 to the power 2,82,641 minus 1, something Mersenne prime. And the formula for finding perfect numbers. Let n be a positive integer for which 2 power n minus 1 is a prime number. Then the number 2 power n minus 1 into 2 power n minus 1 is a perfect number. So perfect number means sum of positive divisors of the number other than the number is itself. If you add the divisors of a number except the whole number, the addition must be the number itself. That is called the perfect number. And suppose you can verify the fact for n is equal to 2, 3, 5, and 7, and so on. Of course, Fermat's lattice theorem, every positive prime and positive integer n, if n is not divisible by p, then the number n to the power p minus 1 is divisible by p. Of course, this is nothing but there is algebraic proof through Lagrange's theorem also. Of course, the converse of Fermat's lattice theorem is not true. And in this regard, first 1 or 2 prime numbers happen to agree with the fact, but the 1 or 2, the sequence of prime numbers, if you take the 102 prime number, it is not satisfying the converse. Of course, a binomial theorem, it is the power of a sum a plus b to the power n is equal to sigma m is equal to 0 to n ncm a to the power n minus m b to the power m. Of course, this is a part of a counting principle. In fact, these counting principles are very backbone of combinatorics, the fundamental think tank of mathematics. Combinatorics is the think tank. Fundamental theorem of calculus, fundamental theorem of algebra. Of course, people know that the fundamental theorem of algebra is nothing but for every nth degree equation, there are exactly n roots. In terms of field theory, the complex number field is algebraically closed. Of course, the prime number theorem, let n be the integer greater than 1. Let p of n be the number of primes between 1 and n. Then limit n tends to infinity, p of n by n by log n equal to 1. That means to say this p of n is almost equivalent to n by log n, natural logarithm. And of course, this is a very long-standing question of 18th century. And of course, the first proof was given by Charles Jean, and the second one, Hadamard. There is a matrices called Hadamard matrices in his name. Of course, De Morgan's law. In fact, this is a very famous problem in number theory. Any planar graph can be colored with 4 colors. If you take map, you have to color the regions in such a way that the adjacent regions receive different colors. Of course, this 4-color theorem, still now theoretical proof is not available, and it is in 1852 posed by one of the South African botanists who happened to be a surveyor. He wanted to create the map of the entire region, and during that process he posed this question, and still now no analytical proof. However, there was a very beautiful computer aided proof in 1976 after 120 years, and of course it is by Kenneth Appel and Haken. And of course, this is a very beautiful algebraic contribution, the characterization of finite simple groups. And of course, this is one of the problem wherein the Fields Medal has been awarded. It's a very beautiful characterization, and every finite simple group is isomorphic to one of the 18 infinite families, or is isomorphic to one of the 26 sporadic groups. Sporadic group means quotient groups of matrices. Of course, Fermat's last theorem, I appeal to the young mathematicians who attend this program. There is a book called Fermat's last theorem by Simonsen, 400 rupees. It is available in Amazon, because we buy so many things in Amazon. You try to get this book. This gives the entire story of Fermat's last theorem. It is like a beautiful novel. You cannot drop the book once you started reading. If n is an integer and n is greater than or equal to 3, then the equation x power n plus y power n is equal to z power n has no positive integer solution x, y, z. Of course, it was proved by Andrew Weil, and there is a very beautiful, very attracting history behind this problem. Just it is a one-line problem, but it has taken so much of effort by 2 people, Taylor and Andrew Weil. Of course, Poincaré theorem, Just I will skip it because I wanted to tell something. Yeah. And regarding development of mathematics, or the people who intended to do research in mathematics, they always, the very first thing is how to identify the problem. Identifying the problem itself is problem in mathematics. The Spanish mathematician David Hilbert, in 1900, German mathematician David Hilbert, in 1900, he posed 23 problems, and still some of the problems are unsolved. And every 4 years, there is a meeting called International Congress of Mathematicians, which is held once in 4 years. And in that meeting, the Fields Medal shall be awarded to 4 people in mathematics. And he posed in the first ICM meeting, and he has presented the conference in Paris on August 8, 1900. The problems are this. The first problem is continuum hypothesis. What is continuum hypothesis? There is no set whose cardinality is strictly between that of the cardinality of integers and cardinality of real numbers. Of course, there is a number called cardinal number Aleph naught. So this continuum hypothesis is the first problem, and it is proved that it is impossible to prove or disprove. Please note that the nature of the problem. One problem is stated, somebody says that it is impossible to prove or disprove. How a beautiful statement is carved. Still, the people say this statement, the continuum hypothesis, cannot be proved, also cannot be disproved. So that is a status. Of course, there is no consensus among the people for some of the partial solutions. The second problem is the axioms of arithmetic are consistent. And of course, there was a proof by Gödel and Getsin, and still now the proofs are not compatible. And in 1931 and 36, it was proved. People say that this is not the solution for the problem stated by Hilbert. And third problem, given to polyhedra, the geometrical figures of equal volume, it is always possible to cut the first into finitely many small polyhedra pieces such that they can be reassembled to yield the second. Two things you are having, same volume, you can cut one into small pieces, you can put it in the other. And it was proved by no, this is not possible, by Duncan invariants in 1900 itself. Of course, this is the very first problem posed by Hilbert, solved immediately, and of course it is not possible. The fourth problem, construct all metrics where lines are geodesic. And people say that this statement is too vague to be stated, resolved or not. And the fifth problem, are continuous groups automatically differentiable groups? It's a part of algebraic geometry, and it was resolved by Andrew Gleason, and it is equivalent to Hilbert-Smith conjecture, which is still unsolved. And of course, it was in the year 1953. Hilbert's sixth problem, mathematical treatment of axioms of physics. So it was partially solved from the year 1933 to 2002. Seventh problem, transcendental numbers, algebraic numbers. The numbers which are not algebraic are called transcendental. Suppose I consider a to the power b, a not is equal to 0, 1, and b is irrationally algebraic, whether it is transcendental or not. And of course, it was resolved. Resolved means it is proved by Gelfand's theorem, by Gelfand-Schnieder in 1934. Gilbert's eighth problem, Riemann hypothesis. The real part of any non-trivial zero of Riemannian zero function is 1/2. Still, it is unsolved, and of course, it has got beautiful implications with Goldbach conjecture and twin prime conjectures. They are all very beautiful components of number theory, the conjectures. Of course, still it is unsolved problem. You please note that in 1900, Hilbert posed the problem. Even in 2022, the problem remains unsolved. Find the most general law of reciprocity theorem in any algebraic number field. It is partially resolved. 10th problem. Find an algorithm to determine whether a given polynomial Diophantine equation with integer coefficients has got an integer solution. Of course, it is proved that it is impossible to find, and of course, it is using Mathias-Schwi's theorem, and there is no such algorithm. It is proved in 1970. And 11th problem, solving quadratic forms with algebraic number coefficients. It is partially resolved. 12th problem, extend the Kronecker-Weber theorem on abelian extensions of the rational numbers to any base number field. Of course, it is partially resolved. 13th problem, solve a 7th degree equation using algebraic functions of 2 parameters. Solve a 7th degree equation using algebraic functions. It remains still unresolved. Of course, some of the variations have been attempted by Arnold and Galmograph. And 14th problem is the ring of invariance of an algebraic group acting on a polynomial ring always finitely generated. The result is no. And of course, it was proved by a counterexample by Agata in 1959. 15th problem, rigorous foundation for Schubert's enumerable calculus. It was only partially resolved. 16th problem, describe relative positions of ovals originating from a real algebraic curve and as limit cycles of a polynomial vector field on the plane. It is unresolved. Even it is not possible to attempt for an algebraic curve of degree 8. 17th problem, express a non-negative rational function as quotient of sum of squares. It is resolved. It is by Emil Artin, the famous algebraist, in 1927. 18th problem, is there a polygon that admits only anisodihedral tiling in 3 dimensions? Of course, it is resolved yes by Reinhardt in 1920. 19th problem, are the solutions of regular problems in the calculus of variation. Calculus of variation means it is finding minimality with respect to time component. It is, maxima and minima. It is for the static functions. Calculus of variations deals about maxima, minima for time variant. It is always necessarily analytic. It is resolved yes by Ennio Digoriri and independently by John Forbes Nash in 1957. 20th problem, do all variational problems with a certain boundary conditions have solutions. Resolve. Of course, this is a very significant contribution in the development of applied mathematics, especially non-linear differential equations. 21st problem, proof of the existence of linear differential equations having a prescribed monodromic group. And of course, it is partially resolved. In some cases it is yes, in some cases it is no. It is still open and it depends upon exact formulations. 22nd problem, uniformation of analytic relations by means of automorphic functions. It is partially resolved. The last 23rd problem, development of calculus of variations. People say that the statement is too vague to be so resolved or not. So I have listed out quickly all the 23 problems posed by Hilbert in 1900. People say 11 problems are solved, 6 problems are solved partially, and 6 more problems are not at all resolved. Okay, now what is the current scenario? There is an institute called the London Institute of Mathematical Sciences, which is an agency created area in London by the British government, which is an agency deals about science policy of that country. They listed out some 23 mathematical challenges in October 2021, and they say that These are the 23 mathematical challenges which is going to be for the future attempt or which is for 21st century. And it is the roadmap for the entire science agency for this institution. Just I will give the list because I am not going to describe. The names are this. If someone is interested, you please type in the net, you will get everything. The first problem is theory of everything. Second one, Riemann hypothesis. Of course, that is a problem by Hilbert also. Thermodynamics of life, the structure of innovation, physics of self-assembly, cosmological constant, Lagrange program, intelligent artificial intelligence, parable instead of rebost, operating system of life, mathematical universe, describing network structure, theory of free will, collective creativity, programmable matter, foundation of QFT. QFT means quantum field theory, which is the fundamental for physics, mathematical dualities, engineerable artificial intelligence, theory of simplicity, artificial intelligent assisted conjectures, mathematics of causality, emergence of virtue, theory of immutability. You please see the names of the problems which are challenging mathematical problems. So they look like almost all these problems, they concentrate on something called the machine learning process, which is a fundamental concept which is being attempted by everyone in the industry now. It is a machine learning. That is what being put forth as an agenda by the international community. Just I would like to inform the young minds that these are the recent scenario in mathematics. So please aware of it. You please, it is not anything very difficult. So it is for the bounden duty of we people in mathematics to know what are the challenges in mathematics, and we should also aim to attempt as a part of the intelligence in the world. So with this, I thank the department for this opportunity. Really, it's a wonderful program organized by Department of Mathematics under the leadership of Dr. Pasanguli Pandian and Dr. Bhagirathi. I congratulate the team for this wonderful arrangement. Thank you for the opportunity.
Thank you, sir.
May I now request Dr. K. Bhagirathi, Assistant Professor of Mathematics, to propose vote of thanks.
Sir, it gives me an immense pleasure to deliver the vote of thanks for this event. First, I would like to acknowledge our gratitude to Dr. T. Tamilchelvam sir, who honored this function for sharing the mathematical concepts in different manner. Sir, in your address, you have mentioned many theorems like Fermat's theorem, binomial theorem, fundamental theorem of algebra, and many theorems in diverse angles. Every time we are wondering about you and your knowledge, sir. Thank you so much, sir. Always you are provoking our learning interest, sir. And I, on behalf of our Department of Mathematics, Adityath College of Arts and Science, I thank you so much, sir. Thank you. And I am particularly grateful to my beloved secretary, principal, HOD, for their guidance and supervision for arranging this conference. Also, I take this opportunity to express my gratitude to several friends and colleagues for their helpful suggestions and encouragement. Also, I wish to thank my sincere thanks to my scholars Saranya and Selvan, assistant professors of mathematics, Adityath College, for their keen interest for preparing the e-proceedings of this conference. And also, I want to thank my colleagues, Dr. Lok Prabhakar and Dr. Kalanjanathan sir, Assistant Professors of Zoology Department, Adityanar College, who work behind the screen to arrange all the technical facilities. And I would like to thank our faculty members, scholars from various institutions and our own institution for making this function as a grand success. Thanks to all the people who helped me either directly or indirectly to make the conference successful one. Thank you one and all. Thank you. Thank you so much, sir.
Thank you, ma'am. May I now request Dr. M. J. Jayanti, Assistant Professor of Mathematics, to introduce the chief guest.
Okay. Good morning, everyone. First, I would like to thank for this opportunity to introduce our resource person, Dr. Prabhu Nadarajan. He is working as a lecturer in mathematics section of Department of Information Technology in University of Technology and Applied Sciences, Al-Musanna, Sultanate of Oman. He did his MSc and MPhil in mathematics and PhD in geomatics engineering. He is having around 19 years of teaching experience in mathematics. His research areas are remote sensing, hyperspectral data, super resolution mapping, and image processing. Hyperspectral data have many applications and are being promoted over multispectral data to derive useful information about Earth's surface. In 2016, he published his research article, Wavelet-based feature extraction techniques of hyperspectral data, in the Journal of Indian Society of Remote Sensing. In the same journal, in 2019, he published another research article, Spatial Resolution Enhancement Mapping of Hyperspectral Image via Pixel Filling Algorithm. Currently, he is doing his research in climate change analysis on Himalayas and further comparison of fractional abundance estimation of hyperspectral data using LMM and ICCSMM. So in this session, we have such an eminent resource person in the field of applications of mathematics via remote sensing. So I hope this session will be very useful to all of us. Thank you.
Sindhura Devi.
Sir, may I now request Dr. J. Rajakumari, Assistant Professor of Mathematics, to propose vote of thanks.
Wait.
Sir, பேசவே இல்லைங்க.
Now invite Prabhu Natarajan sir for the technical session. Sir, may I now request Dr. Prabhu Natarajan to deliver the technical session 1.
Yes,
Welcome
good morning.
you,
Good morning to you all. Yes, sir, whether
morning.
my voice is audible, sir? Yes, sir. Good, sir.
Yes, it is clear.
And I think time lag is there. And can you see my screen, sir?
Yeah.
Okay. I will make it full screen also after some time. Yes. First of all, I hope so you all are fine. And I really be thankful to Dr. Pasanguli Pandian sir for inviting me to give this presentation. And of course, because of this one, I have attended the very first session given by Professor Tamil Chelvan sir. Really, I was really enjoying that session. And after attending that session, I came to know that how much I am far away from my mathematics. That is the point. Okay, so you take me to 20 years back, sir. Really, those terms when you have used for color conjecture mapping and all, they are using mapping. But that 4-color conjecture, that is completely different. It's full mathematical part. Really enjoyed, and you have said that Hilbert 23 problems. Really, they are useful for those who are studying now. They can focus on any one of those problems and they can solve. We did not get such opportunities maybe long days back. That is true, sir. But now during this pandemic session, at least I got such a chance to meet. Otherwise, if it is not through virtual, I might not have attended such session. That is the main thing. Yes, sir. Anyway, I thank the organizing committee for organizing this conference, and it is going good. And here I am in Oman. I thank my department head of department and my section head and my dean and assistant dean for giving me this opportunity. Here I am working in University of Technology and Applied Sciences. It is Al Musanna. It is in Al Musanna, and he last 6 years I am working, and completely here mainly teaching and research. Now only we are going slowly starting and we are moving towards it. We are getting now more chances to do our research. And just 2 points I wish to tell. With that, I will start my session. Yes, recently I have got a project here in Oman, and really it is a very good project. It is based upon remote sensing and renewable energy. That is the reason when Pasangali Pandit sir asked me to give a talk about that one, I wish to include these things also. How mathematics is useful in remote sensing. This was my research work, PhD work, but I have extended further to something related to this project. Okay, this renewable energy, how the remote sensing is useful, how the mathematics is useful, what mathematics we have developed earlier, how much it is useful nowadays. So all these things I'm going to talk. Anyway, if I'm running out of time, please tell to me, because when I start to open the presentation, it will go off. Okay. Anyway, I have lots of slides, so don't panic. So many things I'm going to show as images only. Okay. Anyway, sir, let me start my session. Just I want to know whether it is full screen or only partial is coming, or is it okay? Because here I am seeing.
Is it okay, sir?
Sir,
It is
can
okay.
you make
Is it
it
okay,
full
sir?
screen, sir?
Okay, sir.
That's what I am checking, but let me check one more time. Just 1 second.
Your screen
Yes,
is
sir.
not visible now.
Yes, I have cancelled just to make it as.
Yeah.
Now, can you see my screen, sir? Full screen is there? Yeah. Yes,
No,
yes.
yeah, fine.
Now it is full, right?
Yeah.
Sir, right. Yeah, yes, but now in my screen I can see the complete PowerPoint full screen. I cannot see anyone is there. Okay. Yes. Now I will continue. Yes. Today I am going to talk about applications of mathematics in engineering. We are remote sensing. So, what applications we are doing in engineering, but with the help of remote sensing. So there, where mathematics is being used, I'm going to discuss about this one. I'm Dr. Prabhu Nadarajan, working in Uttasa, University of Technology and Applied Sciences, Al Musanna. In my outline, in my presentation, I'm going to talk something about the color formation, how much colors are important. Okay, about first general images, and also that will be helpful for satellite images. I hope so we are familiar with Google Earth or Google Map images. Whenever we travel to any place, we will use generally maps. Nowadays, those maps are helpful. Okay, so there are mainly 2 types. One is the satellite view or the normal view like a map. Okay, so mainly the analysis, everything based upon the satellite view. It is really very difficult for even people to interpret the satellite view, because all the locations you have to see from the top. Okay, so even if it is a street or road or river, house, building, everything from the top. The way how we see in the street view is different from the top view. Okay, so then some mathematical background, sometimes maybe for this algorithm and all, PCA and the linear system of equations, I will just go something line by line. and how these are useful. So if I give you some 3 equations, you can solve easily. That is true. The same thing, how it is useful in remote sensing, that I'm going to explain. Then a few applications in remote sensing part, how to reduce the images and classification of some types of satellite images. Then about the data sets. Then the main thing, applications in engineering. So the mathematics is used in algorithms for remote sensing, then goes to engineering applications. And then the conclusion. Yes, now I will show you some images. Here you can see flowers. And of course, I planned for interactive session, but I hope so it will take time. So directly, I will just give some questions like this one. Just try to find the colors of any 1 or 2 flowers. Okay, in the next image, I will show you the actual photograph of these images. And you will come to know why colors are important. Without colors, you are seeing. Okay, in earlier days, we had the same black and white TV. Okay, this is called a grayscale. We should not tell black and white because black and white means only 2 colors, black and white. So here it's not only black and white, so many colors are there in between black and white. So it is called grayscale image. Okay, it is just 2 dimension. 2 dimension means I'm not talking about this one. To create this image, we need only 2 dimension. But when we go to the next one, the colors, we get colors because of 3 dimension. Okay, of course, here even though it is 2 dimension, the number of bands, only one band is there. But here, to produce colors, we need 3 colors. Okay, so we might have studied this one in our earlier days. RGB, red, green, and blue. Combining these 3 colors, we will produce any color in the world. That is the meaning. So depends upon the composition of colors, maybe less number of red component and more number of blue component. It gives 1 color like that one. Anyway, I'm going to show in the next slide. Okay, so to produce this yellow color, we need 3 bands. 3 band, B-A-N-D. Okay, anyway, I will write that one also in the coming slides. How colors are formed with the help of RGB. Even in color television, we have these 3 colors, primary colors. These are the 3 primary colors, R, G, and B. So this R is nothing but 100. The meaning for 1 is 100%. For example, we are talking about digital. Digital means every pixel is in terms of bits and bytes. Here, this is for example. Just I am telling for example, it is 8-bit number. 8-bit number means 2 power 8 minus 1. It is 255. That means if it is 100%, means here it is 255. The first number is 255. Then 0 and 0. You will get a color, and this is the color, red color. Please note that there are lots of red color, and of course, maroon is also a shade of red. Like that, orange is also a shade of red. But here it is 100% red is this one. The same thing for green color. In this one, you see here, the red and blue components are 0. Blue color, of course, here it is not visible. So I just put a white color background here. And this is the actual blue color. When you see this one, what is the connection between this one and mathematics? Just for color formation. Color formation is natural. The natural we have taken for any image processing or any color TV or whatever it may be. But this is nothing but basis for vector space. You might have studied this one. These are nothing but vector elements. And with these 3 elements, you can create any element of 3 dimension. That is the meaning. Okay, so just all the properties of vector space, what we have studied, applicable here also. So in engineering, they are just utilizing all the mathematics developed by lot of years back, and it is being utilized here. And the other basis, we have a lot of bases, but mainly these 2 bases we will use. The complement of red. Can you guess? Of course, anyway, I will tell the complement. In mathematics, we are having lot of words like a complement, inverse, opposite. All are different meanings. Sometimes they may same, but otherwise everything different. Okay, so here the complement is C. C stands for cyan. Wherever here 100%, it becomes just 1 minus. That is the meaning. Okay, just subtract by 1, you will get 0, 1, 1. And here also for magenta, this color is cyan, and for magenta, complement of green, and blue, complement of yellow. And for yellow, yellow complement of blue. Both are same. Yes, and this is the color. And I said to you here RGB, these are the base. Okay, basis. The word basis we have used in vector space. In the same way, these three CMY are also the basis to generate the entire R power 3. Now with the help of this one, we can generate, for example, if all are 0, then it is black color. If all are 255, then it is white color. Obviously, it's complement. And here it is how it is formed as a vectors I have explained. And this is the color. See, you can see something from here. Here the maximum number, almost it is 237. The middle one is green domination. And almost it is near to 143, the third element. That means it is 1. Okay, so it looks like this one. See here. Here, 1 it is more, this is more, and here it is 0. It is near to 48, is near to 0. So it is somehow, it is close to the color C. It's a mixture of C and G, we can tell. Okay, so this is the way how colors are formed. If you see any image, any PowerPoint, any paint picture digitally, these are the colors, these are the numbers. Everything stored as numbers. Here I have explained to you the number 0 to 255, but in satellite images, not simply 8-bit, maybe 10-bit, 12-bit, 16-bit. So when we go for 16-bit, the number is 2 power 16 minus 1. 2 power 16 minus 1 is a huge number. Okay, so what will happen when we are having an image of 100 cross 100 pixel? Each element is of 2 power 16 bit, means the capacity is huge. So we need a lot of technique to reduce that one. So everything, the background is mathematics. Okay. Anyway, so, and one more point I will tell here I said the primary colors are RGB, but when we take printout, there the same RGB you will not see. In color printer, you will not see RGB, you will see CMY. Okay. With the help of CMY, you can produce black color also. But generally, it is cost effective. So in color printers, they will add one more color, black. For white and black printout, they will just give that printer will take directly black color instead of combination. Okay, only for this color mixtures, it will take, because when compared to RGB, this CMY is easy and cheap. Okay, now we'll go for the next one. Elements of visual image interpretation. When you see an image, how we will interpret. Now I will show you few images here, and what are all the techniques required. We'll see. With the help of color or tone, we can identify. For example, earlier I have shown you one image, images of flowers. Okay, so in that one itself, we will come to know how the colors are important. Texture, all I will show you examples in terms of satellite images. Of course, the Google Earth images. Shape is important. Size, the help of size, we can, everything visual image, not computer based. But nowadays we are having algorithms for these also. How shadows are affected, sight or association, pattern. So these are the 7 elements of visual image interpretation. Here I will show few things. Can anyone guess what it could be? The image of, this is from a Google Earth image, that means satellite image. Google Earth image is nothing but combination of satellite images. Okay. Yes. Anyway, I will just say you might have guessed by this time. So here, this is river Narmada. So if this is river Narmada, this is nothing but Taj Mahal. Okay. So this we can able to identify. The same thing here. It is in Oman, of course, because I am here in Oman, I just take this picture. And this is Sultan Qaboos Grand Mosque in Oman. And here, what it could be. Yes, because of the colors, you can tell this is nothing but it looks like a mountain. Yes, it is a mountain. And in one single image, there are a lot of things we can see. In this mountain, you can see the shadows. When shadows are there, that means either there is a deep hole inside or there is a mountain here. I mean, mountain means skill point, peak point may be there. Okay, here also you can see the shadows. When we process satellite images, the shadows are really a very thing which we have to reduce. Okay, because this will completely divert the one which is lying there. Okay, and the texture you can see here, it is smooth, but here it is rough. So many things in visual interpretations we can see them. Colors, with the help of colors we can tell this is nothing but snow. Here, what it could be? Can anyone guess? It's this green color. These are nothing but vegetation. Vegetation. It is in North India, near to Chandigarh and its surrounding areas. Okay, completely greenish, but here some few dots are there. What are they? So they are nothing but small dots are villages. And the one big, they are, of course, big urban areas, cities or towns or municipalities, something like that one. Okay, so here the Himalayas, you can see in the top right-hand side corner. The left-hand side, of course, near to Pakistan, we can tell. Texture, see, it's one single image. You can see here it is smooth texture and here it is rough. And please note that when we talk about texture, smooth and rough, it is not about the place. Okay, you can see suddenly the color variation, lot of variation is there. Okay, I'm not telling the place is rough. Earlier I have shown you here, the place is rough here. Okay, not like that one here I am telling. So here it is, the texture is rough. So 1 pixel dark, 1 pixel light, again dark, light, some combination like this one coming. So it is rough texture. Next, I will go to shape. The help of shape, we can identify what is this building. Okay, how many sides are there here? 1, 2, 3, 4, 5. 5 means pentagon. This is pentagon. The same way here, this is circular. Of course, there are so many buildings which are circular, so it is really difficult to guess. And this is our parliament. And this one, with the help of shape, you can find. This is pyramid. And here, size is important. Okay, so here you can see two sizes of buildings. Here you can see a big building. Okay, and here you can see some small buildings. So here the small buildings are a residential area and the bigger one is something like office or school or college or malls, like that one. But here you can see a ground also. This is nothing but Adityanar College of Arts and Science. Okay, just to show this one, I have taken shadows. With the help of shadows, we can identify something visually, but shadows, really it is a curse for in image processing. See, you can see here, this is Burj Khalifa and it's a shadow here. You can see the shadows. So with the help of shadows, we can tell, we can guess the height of building also. Pattern. Here you can see here in the top two images, no pattern is there. Okay, so this is for example a forest. In forest, the trees are not arranged in patterns. Okay, even though there are plenty of trees, we can tell they are not arranged in any pattern. But these two, if you see, of course, what are these trees? You might have guessed by this time. And some pattern is there. We are arranging even when we are having crores, when we are planting crores of paddies, we are arranging in order. That is the beautiful thing. Association, of course, almost this one and the previous one, both are same. Okay, so here you can see these are coconut trees, and here. Can you tell which one is coconut? Can you guess which one will be coconut? Here also coconut trees. Here also it looks like a coconut, but the word association is helpful. This image taken in South India, okay, Madurai and its surrounding somewhere. This one taken in Oman. So the association means in Oman, particularly in the northern side of Oman, no such coconuts will grow. So these are nothing but date trees. See here, visual interpretation both looks like same, but with the help of association. Of course, association means somebody should tell from where it is taken. Okay, according to that one only we can guess. Even though both looks like same, we have to, with the help of association, we can find. But when it comes to satellite image processing, the view is completely different. Not with the help of association, not with the help of size, shape. Even though size, with the help of size, with the help of shape, we have one type of analysis. But what I have done in my research work, or what I am going to talk to you about now, everything is something only related to colors. Mainly, there are three types of remote sensing: optical, thermal, and microwave. Optical is what we are seeing. Thermal is based upon the temperature. The time is less, so let me go further. Microwave is like how the bats are seeing. Microwave sensors, with the help of microwave sensors. So see, for everything, advantage is there, disadvantage is there. Okay, during nighttime, optical remote sensing will not work. That means if no light is there, how we can see or how we can take photo? So we need a flash. That flash will be given by microwave. That means microwave is nothing but they will throw something, the reflection it will catch at another place. Okay, so even if it is dark, it will take only the roughness in the roughness of the object. Thermal, it takes the temperature. Okay, so daytime we take one photo, or nighttime it is different. And one more thing, they are useful whenever there is forest fire. The main source, what is the source of fire, we can able to find. In case of instead of finding the forest fire means it's a huge area, it will. Okay, but where is the fire? The smoke will affect. From when we see from the above, in the forest fire, completely smoke will be there. Okay, optical remote sensing, it will only take photo of smoke, not the exact place where it is inside. But in case of thermal, it will take the temperature inside. So in this way, this is useful. Anyway, today we are going to discuss only about optical remote sensing. So optical means mainly the idea of physics concept comes into the effect. Visible, near infrared, short wave infrared, mid-wave, thermal, these are the ranges. And at the very beginning, I have shown you some images of flowers taken in our ordinary camera. All ordinary camera we are having between the wavelength between 0.4 and 0.7 nanometer. Okay, no, micrometer. This is micrometer, or otherwise 400 to 700 nanometer. Okay, so only this one, but that is not sufficient. Only with the help of red, blue, green. What is the problem? Just now I have shown you here. This is also green color. This is also green color. In case of Google Earth image, I have collected as an image. So this is just RGB image. So this is also green color. This is also green color. In both the things, we'll see only this green color only. So this is not sufficient to identify what is this species. Every time we cannot go for association. Okay. So in that regard, when we are going for further wavelengths, okay, there we will see the difference. Okay. So if you see in mid-wave infrared, dates and coconut will show difference in pattern. With the help of that, we can identify the species of the plant. Not only those two, all vegetations like that one. These are the platforms of remote sensing, aircraft based. The camera will be set in aircraft or satellites. These two are the old aerial photographs and balloons earlier days. And some sensors. Okay, whenever we see in a newspaper, PSLV is just a rocket. It will just launch and it will put the satellite on the sky, on the space. Okay, so there a small box is there. In that one, sensor is kept. Okay, that sensor is the heart of the entire process. Okay, so these are the sensors. Some names, so Avery's, Cassie. There are thousands of satellites. I mean, revolving there. Traffic jam is there, and we have n number of satellites placed there. Okay, so now it is easy to monitor all the places, all the countries, depends upon the need. These are some other satellites. Anyway, I don't wish to waste time here. Types of remote sensing satellites, mainly two types: geostationary or equatorial satellite, another one sun synchronous or polar satellite. That means one satellite will revolve around the earth. See here, for example, the sun is at when the satellite is coming here, the time is 2 o'clock. Wherever the satellite is going, it is 2 o'clock. Uniformly it will take. That is the reason the satellite's path is different. Please note that to design this path, we need the locus of earth, locus of revolution, rotation, and the satellite also. For this one, the geometry which we have created 1,000 years back are useful. Okay, because these all are engineering concepts, physics concepts. Okay, but without that mathematical concept, they might not have think about this one at all. Yes, this one, what I said, this will, for example, we are having satellite, we can monitor the entire Earth. But here it is geostationary satellite. This will, the mean name itself tells geostationary. Geo means Earth, stationary means fixed. Okay, so it will, throughout its lifetime, it will monitor one particular place. When I tell one particular place, maybe one continent or maybe one country, and so on. This is very much helpful for meteorological studies. Okay, so they're telling, okay, today it will rain, tomorrow it will rain, something they're telling with the help of this one. Okay, for this one, if the satellite is very close to the Earth, we cannot able to monitor. This is kept 36,000 kilometers. See, geostationary around 36,000 kilometers it has been kept. Then only we can monitor the speed and speed of the clouds, direction of wind, everything. Okay, so with the help of satellite images, we can check even the temperature at a particular place. Even we can find the speed of the wind. So many things we can do. Okay, so the way how it will take the pictures, this is very important. Various types of resolutions. So resolution means in one single pixel, how much information is stored. That is called resolution. So that is called spatial resolution, but there are few more resolutions also. Okay, for example, here you might have seen some sensors I have mentioned. So there you can see the term Landsat. It is 30-meter resolution. The sensor name is Landsat. It belongs to US, 30-meter resolution. That means, for example, if you have a satellite image, okay, like this one, this is 1 pixel. In this 1 pixel, this information here, it contains information about the Earth, 30 meter. See here, it's a square. So this side also 30 meter, this side also 30 meter. It is 30 cross 30 square meter resolution data. That means in this 30-meter resolution, if a road is there, building is there, means the color will be a combination of both only. One single color will be there. If this is 1 pixel means, if for example, if it is a road means it is completely black color. If it is road, if that particular thing is road, it is completely black color. For example, if the next pixel is a building, the building top is white color means, okay, let me take a small, okay, for example, the next one is white means this is completely white. But what will happen if the next pixel is mixture of road and this one? So percentage depends upon the percentage of road and building, the color will be gray color. Okay, so one single color will be given to 1 pixel. So that is spatial resolution. Very complicated. Think about 30-meter resolution. In India, 30-meter resolution means you can see it will cover the entire street. Okay. Anyway, so here, spectral resolution. In the very beginning, I said you have grayscale images, black and white image, only one band. Band 1, only one band. Next, I have shown you color images, red, green, blue. Band 1, band 2, band 3. Okay, 3 colors, band 2, band 3. This is called, so here the spectral resolution for the photograph, what we are taking is 3 only. Okay, but in satellite images, 7 is there. For Landsat, it is 7. For there is another one, mode is 30. 30 means 30 bands are given. Not only that one, 242 bands. You have seen before Avery's 242 bands. Okay, so more or less they are same, but which band is suitable? We cannot delete anything without analyzing. So see here, so completely closed like this one, it is arranged. So that is the reason for we can able to identify difference between a dates tree and coconut tree, between paddy field and any other greeneries, grass or wheat. Okay, Radiometric resolution. Now, just now I have shown you here one image. This satellite is revolving. Okay, this is temporal resolution. The next time when it will come to the same place, that is nothing but temporal resolution. Radiometric resolution means that also I have discussed 8-bit. That means 1 pixel is of 8-bit. Okay, so the radiometric resolution is 8-bit, but it may be 10 bits also, or 16 bits also. Images we have. When the bits are increasing, the clarity, the way how we can identify that is also increased. At the same time, the complexity in algorithms. Okay, the algorithms, the workstation which we are working, they are very much important. Okay, so 16-bit image means the software and the computer should be strong enough to work. Okay, otherwise we cannot. Even I have a data, because for example, one movie generally it will be around 300 MB. Yes, it is 300 MB. Okay, for one satellite image, it will be 800 MB. So three movies we can put it in that one almost. So that much of capacity we want to take and work. So this is the way. So here, so if the sensor, like if the spectrum is from one complete this one, the wavelength, if we take the complete wavelength as one band, it is panchromatic. That is black and white. What I said. The same thing with many bands. You can see here. Here it is red. Here band number 3 is red, green, and then blue. Generally, this is for multispectral. For hyperspectral, see the range is same. Range very earlier I have shown you some range 0.4 to 0.7, 0. Up to here you can see 14 micrometer. Okay, the same thing here it is mentioned. But how many bands? Here, how many bands we are getting? Filters 1, 2, 3, 4, 5, 6. So here hundreds of bands. Ultraspectral, not we are using in satellite images, but in medical images this is being used. Okay, because you might have noticed nowadays, so doctors will do operation by looking at the computer monitor, not to the, because some operations inside the body they are doing through computer monitor. For that one, what is exactly that one needs to be identified. So these things will be helpful. Now, hyperspectral images means, I said, not simple one band, many bands. All are of same size. That means if I take pixel number 1, that means first row, first column element pixel, all this one will tell about the same place, but different numbers or different colors, depends upon the band, depends upon the reflection. Okay, so this is nothing but a hyperspectral image, looks like this one. This is in Dubai, Palm Islands. Okay, so you can see. So how, just now I have said to you this one. For example, in single pixel, this is 1 pixel. 3 or 4 colors are mixed in each. For example, 30% red, 30% green, 35% blue, and 5% yellow means what single color will come. And of course, how to calculate this one I have mentioned here. And here are the patterns. For example, I said to you, hyperspectral from 0.4 to see here 2.4 micrometers. In this one, see 0.4 to 0.7, almost 7 is visible. Okay, in our ordinary camera, we will take images only this red, green, and blue. Okay, so we cannot able to find from the next one. If you see here in this band, okay, anyway, if you see here at this place, so this maroon color, it is wet soil, and this purple color is turbid river. Both are same values, and also the green color is vegetation. All are same. So if you take one band image, it is kept at nearly 0.59. All these will reflect and give the same digital color. Okay, so with that single color, it is difficult for us to identify. So we are going for multispectral. So we are going for hyperspectral. Here it is like this one. This is for one band. I'm specially taking for one band. It is maybe something near to 0.8, where it is touching. So here. 1, 2, 3. These places are noted. Green means green, orange, like this. So the calculation I have shown here. Okay, see here. The same way, 30%, 50, 5% 35, 30% 15, 35% 5, you will get a number 23. If you want it in 255, you have to do the scaling. If you want to 8-bit or 10-bit or 12-bit, 16-bit, according to that one, this will be scaled. Okay, this 23 in 8-bit is different from the 23 in 16-bit. It should be scaled properly. Okay. Okay, so just to go to the next one, just to tell a lot of problems. So a lot of dust in between. Reflections are there. Reflections, so many things are affected. Okay, so not simply it's a small distance between the photograph and this one. Okay, the sensor is moving, the object is moving, Earth is, everything is moving. Then also we need a very clear picture. So many images they are taking will be with some small error also. So there are algorithms to rectify them. Yes, the mathematical part here, principal component analysis. This is not only used in satellite image processing, it's a statistical tool. Without statistics, there is no statistics we have used for only what is this one for decision making we have used, but here for algorithms we have used, generation of complete algorithm for processing we have used. Okay. So here this is nothing but just RGB we can tell. For example, this is RGB. For example, if you have an image here, I don't wish to write it because some images are there. Anyway, for example, if you have an image like this one, 3 bands are there. This is for red, band 1 red, blue, green. So all the pixels I will arrange in one column. Okay, for example, here it is 10 cross 10 image, means there are 100 pixels here. The same way there are 3. So there are 3 times 100 pixels. So all the 100 elements are arranged in single line. This is for red band, this is for green band, this is for blue band. Okay. Now please note that if I use this one completely, I will get the information. I can extract the information means like a classes. Okay. I will explain that also. So to do this one, first find correlation matrix. Correlation matrix, correlation between red and green, correlation between red and blue. So you will get a 3 cross 3 matrix. Okay, so correlation between red and red is 1, obviously. Blue and blue, green and green is 1. Correlation it has mentioned. This is just a mathematical calculation how it comes. Then lambda is nothing but our eigenvalues. So please note down what are all the mathematical concepts involved in simple image processing. We think it's very simple one. Okay, but lots of concepts in single process to solve single problem. Okay, so with the help of eigenvalues, of course, we will find eigenvectors. Then with the help of eigenvectors, we take 1 or 2 or all the 3 eigenvectors. And then we will create new image. Here they have taken only 2 eigenvectors. With the help of those two eigenvectors, they have further transformed. See here. The earlier one I have shown you here, RGB. This one is transformed into this one. But there's a question. The image, the values here, they are looking very polite, we can tell. Okay. But here it's so hard. But why we need this one? Here this R means it contains information about red only. G means it contains information about green only. Okay, but in this one it is a transformation. If I take only the first one, only the first column, it is not same as R there. This first column alone contains information about red also, blue also, green also, blue also. But with some various percentage that can be seen from here. See, if I take only one component red here, only one, I will get 86% of the entire data. But here we cannot tell. If I take only this R, I cannot get 86% of the entire image. That is the advantage. So we no need to see the number is simple or complicated. Okay, so we want to see the transformation. You might have studied if you're doing any transformation, Fourier series, Fourier transformation. If you see after transformation, the numbers look like complicated. Okay, why? Because we can extract information from there. This is one mathematical point. This PCA This is principal components you will get. From this one, you will get principal components. This is principal component. This principal component 1, principal component 2, and the last column, principal component 3. Okay, so which one is required? We can take that. Then our linear system. We have already studied this one, so let me go just a little fast. So anyway, the story is okay, father and son. Okay, son purchased some apples and oranges for some amount. He does not know the individual price. The father also purchased something, the same apples and oranges, maybe different ratios for different price. Okay, now how much is the price of individual? To solve this one, generally we will go for linear system. Okay, this is the way how we have used for linear system, right? Anyway, so here he bought 5 kilograms, 3 kilograms oranges, here 8 and 3, and the price. So how naturally we will solve, you know that one. Just you multiply these things by x, because x only I want to find, y I want to find. X is nothing but 1 kg of apple, how much? 1 kg of oranges, y. That we want to find. So how we are using this one? Exactly the same way, the same. You see, that's what I said. It's a very simple one. It's a very simple one to find. Okay, if it is 2 cross 2, you can find. 3 cross 3, you can find. But what will happen if it is 3 cross 2? 3 equations and 2 unknowns, or 2 equations and 3 unknowns. Okay, so all these things, because these are problems created by us, we can go. But when I said there earlier, 242 bands, 242 columns here. Think about a matrix, correlation matrix and all. Okay, there, if you are taking even less number of bands, the complication starts. Not only that one, here they both have got for same price. For example, if the father is getting for a discounted price, and it is, for example, instead of 444, if it is 440, the same linear equation solution will not be helpful. With some small something we will use called error. The concept of error comes in remote sensing, that we will use there. So hyperspectral data, yes. So already we have discussed hyperspectral imaging consists of occurring a scene with numerous narrow and contiguous spectral bands. That means red, green, blue. Oh, sorry, red, green, blue. Okay, in red there are 10 bands. In green, 10 bands. It's continuous and small. That is narrow, very small, and it is not continuous. Continuous in mathematics is different. This is contiguous, like a bar graph, you can tell. Okay, once it is finished, the first band, the second band starts from the next immediately. Okay, that is called contiguous spectral bands. Applications. Okay, it's lots of applications. So these are the types how we can represent wages. Anyway, I think I have 15 minutes. I can finish. And here, yes, this is nothing but with the help of graph. 1 pixel. This what you are seeing is 1 pixel graph. Okay, like this one, for all the pixels you have to draw. Then the same thing we can represent in dimension also. This is here only 2 bands, so only 2 dimension. In color images, what I have said to you, 3 bands, RGB, 3 dimension. In multispectral, I said 7 or 10. We cannot even imagine 10 dimension. Think about hyperspectral, 240, 220 bands. Okay, so some representation not suitable. Vector space is suitable there. Okay, like 240 tuples we will write. Okay, we will tell that every person's gene is some 30,000, it depends upon 30,000 elements. Like that one, every image, every single place is depends upon those many tuples. Okay, so 240 tuple letter. It's a vector of dimension 240. 1 cross 240. Of course, it is a vector. Processing of a hyperspectral data, feature reduction. To do feature reduction, the earlier one we have used PCA. PCA is only one technique. But like the PCA, there are hundreds of techniques we have. Everything with mathematics. The different mathematics, maybe statistics or this one, that one, everything is used. Classification, mainly two types of classifications. One is per pixel, another one is subpixel. Per pixel means one pixel. For example, I said to you earlier, road and buildings are mixed together. For example, it is 30% road, 70% building. Means, okay, we'll tell, okay, the pixel is completely allotted to building because that is majority. Okay, that is, so that means the output of this classification will tell that pixel is completely building. Okay, when we come to subpixel classification, it will tell 30% road and 70% pixel. That means the answer we will get like this one. For example, this is road, this is building, this is water, this is what any other thing, sand. Okay, just only 4 I have taken, but in reality there are lots of classes. These are called classes, so we are called classification. For example, I said 30% road, it is 0.3. Building is 70%, I said it is 0.7. No water, no sand, 0, 0. See here in images, we got one vector, 242 vector, element vector. Okay, that vector is now transformed into just vector of length 4. Okay, of course, this is the reality. But for example, if you get the output not exactly 0.3, sometimes we'll get 0.2, 0.6, maybe 0.1, 0.1 error. Because it is just a mathematical. It is not only looking. It is not only looking at only this pixel. Okay, based upon the other training pixel, what I give, it will match. Okay, so when the Tamil Selvan sir was talking about machine learning, here this is nothing but completely machine learning. It learns them. It's a machine. What is this one? The machine is learning all these things. Okay, that means the input what we are giving, the sample what we are getting, it will match and it will tell the output. Okay, in that one some error will come because maybe the building and water may be same color, or road and sand may be same color. Who knows? So that type of error will come. Okay, so that is subpixel. But there is some advantage in subpixel classification also. Usually subpixel classification, the accuracy will be 60%. If it is 60% accuracy, it is a very beautiful, it's a very good algorithm. Anomaly detection, okay, just to find any simple place we'll use. Anyway, military purpose, they will be using this one, super resolution mapping. Because of less time, I will go further. Feature reduction. Okay, why we need a feature reduction? Because neighboring bands are highly correlated. We have to reduce. When more number of bands are there, when we use it for classification, more error will come. So to avoid, we will reduce 240 bands to less number, maybe 10 or 20 or even 50. Depends upon the algorithm. Okay, so here these are the few techniques where we are using this one, feature selection, feature extraction. Selection means 242 bands are there. Choose number, band 1, band 5, band 10, band 50. That is selection. Extraction means here, feature extraction means transform the given data completely transformed to new set of data. 242 converted into 242. Depends upon take first one or second one or third one or first few. Okay, that is feature extraction. Lots of things. All are mathematical concepts. Without mathematics, here nothing can be moved. Anyway, so you can see this one. Okay, so here it is band 1. I said it to you earlier, very long, band 1, band 2, band 3, like this one. Here we are having, for example, 240 bands. For that one, see, you might have written like this one. So band 1 here, band 2 here, band 3 here, like this one, up to 242 bands. Okay, for this one, find correlation matrix. That means this is also band 1, band 2, band 240. Here I have mentioned, so same 240. 240 or 242 doesn't matter, depends upon the satellite image, what is this one, spectral resolution. Okay, so here, what is the advantage of finding correlation matrix? This one, if you see here, this is of here, the first box is completely white color. That means these are all highly correlated. These are highly correlated. Here, if you see here, this black color not correlated with the first set. So this will become one set. This will become one. Now apply PCA to this one. Apply PCA to this one. That means band 1, band 2, band 3, band 4 up to band 10. Then band 11 to band 25. Another PCA. Take the first few elements. Not only PCA, I said, whatever any other here extraction techniques I have said we can use. Okay, with the help of them, we can extract more information with very less number of transformed data. Here it is. So classification, linear mixture model, what I have explained, the linear system. And of course, these are support vector machine, independent component analysis, everything here statistical based. This is optimization based. See here, you can see here there are two colors. Okay, so which line here will divide these two colors? Which line will divide? There are lots of lines you can see. Okay, but which one is the optimum we will choose? Anyway, I don't have those images. Not only this line, if you see here, not only this one, you can see a lot of lines. For example, if you draw a line here, this also divides these two colors, classes, red and green separately. Okay, here there is another color, another line. See, if I can draw two lines, infinite number of lines in between I can draw. Okay, there are infinite number of lines, but among them only one we are choosing with the help of this idea. Optimization is very much useful here. Okay, based upon the training data, we will choose this one, and then the actual pixels we will give to run the data. Then comes the linear mixture model. See, this is the linear system, what I have said. In the earlier problem we have discussed with apples and oranges, there is no concept of this E. Error is not there. Okay, because I said that there is no discount or actual prices. If they are also coming, error should come there. But usually in schools and colleges, we will study just only about how to solve. Okay, anyway, it's the students' interest to go further and study. And here, this error idea will also come. We have to find here F. F is the fractional abundance. The meaning is, just now I have shown you, road, building. So how much is there? 0.3, 0.700. This is fractional abundance. To find this one, what are all the things I will give? I will give the total price in that story, what I have shown. It is nothing but the pixel value. How the pixel value comes? The DN we have calculated already the same way. Okay, so this is given. M is end member spectra. The meaning is, for example, if it is road, in this 242 bands, what is the number in the first band? What is the number in the second band, third band, fourth band, fifth band? 242 band. Okay, that machine learning concept comes here. This will be given input. Based upon this one, this will be created. Okay, so X is nothing but the decimal number. No, what is this one? Yeah, the decimal number, what we have created there. M is end member spectra. F is fractional abundance. The answer, what we are supposed to get, with E to be minimized. So optimization technique comes again. So linear mixture model is useful, and we can able to find it. Now I think directly I'll go to. Let me directly go to this images what we have created in my PhD. What I have got, I will tell. After then, what I am working today, I will just show here. This is SVM output. SVM means that support vector machine output per pixel. Here is the image. You can see. You can see here. This color, every color is of one class. After classification, the output will show 1, 2, 3, 4, 5, 6. Of course, there are nearly 12 or 13 classes. So 1, 2, 3, 4, 5. For class number 1, we will give one color. Class number 2, another color. Okay, the coloring we have given artificially, but the output is like 1 or 2 or 3 or 4, like that one it will come. Now for LMM classification, of course, there are a lot of data sets. Here it is. Here it is. This is the same image what I have just now shown here. For the same image, the LMM. You can see here This is one. This is the actual class. You can see in the middle, alfalfa. Okay, the name of the plant is alfalfa. Wherever white color is there, you can tell they are alfalfa, but it's full of error. This is error. Here they are not really alfalfa. They are some different classes. But then also here it is because all are vegetation. You can see here all these classes: alfalfa, corn nuttil, corn mint, corn, grass or pasture, grass or trees, grass pasture, like this one. All are almost having same type of signature, the pattern. So it finds difficulty in classifying, and so with error. But then also for us it is advantage, so we are doing. Okay, anyway, just let me show you just few images. Just run, you can see them. This is hay windower, so this is here and here and here, 3 places it is mentioned. Oats, that is the reason I said. So at the end, what is the percentage of accuracy? Means it is only 60% or sometimes 50. Here also you can see this one, urban area, river and vegetation and barren land and all you can able to find with the help of satellite images. Okay, LMM outputs here. You can see here some buildings. You can see here. This is another type of building. This is road. And why here it is black color and something aeroplane? This is nothing but a military field, air base. Okay, so it wherever white color is the road, that means here when the photograph was taken there was an aircraft, so it hidden. Here in remote sensing in engineering applications where we are using. So recently this book chapter I have published, I said to you earlier, estimation of solar energy. So we want to see the solar, we want to keep solar panels. Okay, it is nearby Bina River Basin in Madhya Pradesh. Okay, here this is India, Madhya Pradesh, and the location is here. In this one, we do classification. 4 different dates data has been collected: 2000, 2009, 2014, 2017. Landsat with 30-meter resolution data. Classification has been done with the same 5 classes: urban, barren land, vegetation, agriculture, water. Okay, see how it is transforming from 2000 to 2009. You can see the vegetation cover here increased. Okay, here also. Here at the same time, here this urban land is increased. Urban area is increased in 2019. But you cannot see the barren, very less. You can see very small portion. Please note that in this image, it looks like small. But reality, it is the kilometer, it is nearly 5 kilometers. This one, this barren land is nearly 5 kilometers. The one same thing I have made it as big and I have shown in 2019. Okay, that means from 2000 to 2019, it looks like barren land. The meaning for barren land is, okay, it's not simply vegetation, no vegetation. It means even if we give water, this will not produce any vegetation. That is the reason for barren land. Okay, not like a desert. Desert means we pour water, it will plants will come. They are not barren lands. So there's a difference between sand, soil, desert, barren land, and everything. Okay. So how they are useful? So here it is site location. For this one, the data has been collected. It has been transformed, feature reduced. Then we have done classification. With the classification, we have done for all the 4 images, we have done classification. And from this one, regularly we are watching that barren land is barren land always. So that is useful for site for solar panel fixing. That is the conclusion. But not only simply this one, we can use for this solar panels. You see, this is the earth. Okay, so the sun is in the left hand side here. The earth is revolving, and all these things they have given North Pole, South Pole, Antarctic Circle, Arctic Circle, everything. If the earth is like this one, there's no problem at all. But it is tilted at 23.5 degrees. So the mathematics, astronomy, astrology, and now remote sensing, all these things are really into effect and difficult for us to process because of this reason. See, the next one is the actual earth is spherical. But to study, we have to extend it like a plane projection. The idea of projection comes here into this one. Even in projection, there are lots of type of projection, parallel projection, central projection. Okay, and so in remote sensing, even there are lots of types of mappings are there. Okay, so here to fix a solar panel, we need to know about the sun, which angle it will come. You might have noticed today the sun will be at one place, tomorrow it is little tilted. To know the difference, take 2 dates, especially June 21st and December 21st morning, for example, 7 o'clock. Okay, check the shadow. We cannot see where the sun is. We can see the shadow. They both not will be in the same place, complete opposite place. Okay, so the angle of when, on what day, which angle is very important. To calculate this one, they have already calculated this one. Okay, azimuth angle. To find, of course, zenith angle. These are very much helpful in finding the sun's location so that we can find the shadows. To find this one, this H dash is required. To find H dash again, see here, H dash is nothing but topocentric hour angle. To go further, not only this one. So like this one, when you go backwards, it requires nearly 40-50 equations I have seen. Okay, so please note that with the help, even before the introduction of remote sensing, before the introduction of need of this much energy, renewable energy, everything, astronomy played a big role earlier. They have done for that one full and full trigonometry, geometry, everything plays a good role. Those things we are using here. So at this place, I wish to conclude now. So we can extract information from any part of the world. Even US is having some satellite images, not satellite, it may be aircraft images. The car number we can able to find from the images. Okay, that much accuracy they are having. Requires contribution from mathematics, physics, and computers. Without computers, we cannot do. Without mathematics, also we cannot do. Even though I have mentioned physics, not only physics, biology also useful to study about vegetation. The properties we want to know. A green color tree is different from a green color mat. Biology is required. So they are rich in algorithms and applications to solve the real world problems. So this, I finish this talk. So thank you for giving me this opportunity, sir. And thank you for you all to listen with this much patience.
Thank you, sir. Very nice. Thank you, Professor. Very interesting and nice.
Sir. Thank you, sir. Thank you.
Very interesting.
More informative sessions, sir.
Yes, ma'am. Thank you, ma'am. Thank you very much.
Thank you so much, sir. Actually, nowadays we concentrate only pure mathematics, sir. But today you have provided a very good application size in mathematics, sir. Suppose
yes, yes.
This is an offline mode, definitely we get more from you, sir.
Yes, yes. Anyway, soon it will come into natural life. You will see that. Thank you very much.
Sir. Okay, sir.
May I now request Dr. J. Rajakumari, Assistant Professor of Mathematics, to propose vote of thanks.
Can I start my vote of thanks, sir?
Yes, yes. Start.
Okay, sir. Very good afternoon to one and all. I am very happy to propose vote of thanks in today International Virtual Conference on Current Scenario in Modern Mathematics, organized by Department of Mathematics, Adityanar College of Arts and Science, Tirchandur. Next, I would like to thank our chief guest, Dr. Prabhu Nadarajan, a lecturer in Mathematics section, University of Technology and Applied Sciences, Al Musanna Sultanate of Oman, for his attractive talk on application of mathematics in engineering via remote sensing. Also, I want to express my sincere gratitude to Professor Dr. Prabhu Nadarajan, who spared precious time from his busy schedule to grace this occasion and enlighten all us with the innovative ideas and how to apply mathematics tools in remote sensing field and how to analyze data using mathematical operation in remote sensing field. In particularly, we are liked color coding information section and types of remote sensing section, linear system section, where he mentioned the need of optical remote sensing and platforms of remote sensing in this webinar. Sir, your research ideas and applications in remote sensing field are very useful to our current PG students and research scholars for doing their research in future. Thank you, sir.
Thank you, ma'am. Thank you, sir.
Once again, our heartfelt thanks to Chief Guest Dr. Prabhu Nadarajan for this valuable and informative presentation. Thank you, sir.
Thank you, ma'am. Thank you.
Once again, I thank you to one and all. Thank you.
Thank you, sir. Thank you very much.
Thank you, sir.
madam.
Thank you. Thank you.
May I now request Dr. S. Nityananda Jodi, Assistant Professor of Mathematics, to introduce the chief guest.
Respected Principal Sir, respected Secretary of Arikanar College of Arts and Science, respected Head of the Department of Mathematics, Dr. Pasumuli Pandian Sir, dear colleagues, all faculty members from various colleges, and dear students, very good afternoon to all. So, முருகப்பெருமானின் ஆறுபடை வீடுகளில் இரண்டாம் படை வீடாக திகழும் திருச்செந்தூரில் மக்களின் அனைத்து மக்களும் கல்வி கற்க வேண்டும் என்ற உயரிய நோக்கத்தோடு தமிழர் தந்தை சீபா ஆதித்தனாரால் நிறுவப்பட்ட சீர்மிகு ஆதித்தனார் கல்லூரியில் கணிதத்துறையின் சார்பாக நடைபெறும் பன்னாட்டு கருத்தரங்கிற்கு வருகை தந்துள்ள அனைத்து பேராசிரியர்களையும் நாளைய கணித மேதையாக வர இருக்கும் அனைத்து மாணவ மாணவியர்களையும் இந்த அமர்வுக்கு வரவேற்கிறேன். With blessing of God Chendil Andavar, I am very glad to introduce our resource person of this session, Dr. K. Selvakumar. He is working as the Professor of Mathematics in Manomaniyam Sundarnar University. He did his UG and PG degrees in St. Xavier's College Autonomous in Tirunelveli. He cleared CSIR NET exam in 2004. He finished his DAMPhil and PhD degrees in Manomaniyam Sundarnar University. His area of research is algebraic graph theory, and field of specialization is algebra and graph theory. He has completed one UGC major research project and one DST CRB project. 5 research scholars finished the PhD under his guidance, and 6 scholars are doing PhD. He published 46 papers in national and international journals and 10 papers in SCI journals. He is an active member in UG and PG Board of Studies of Manomaniyam Sundarnar University and various autonomous colleges. He is a coordinator of UGC NET set coaching classes in Manomaniyam Sundarnar University. In general, he is a versatile person, so I feel very happy to introduce such an eminent person in this seminar. On behalf of our mathematics department and our college, I am very proud to welcome you, sir. Once again, I welcome all of you. Thank you.
Thank you, madam. Thank you, madam, for your nice introduction. Good afternoon to all of you. First of all, I thank the organizer of this conference, and especially I thank Dr. Pasumuli Pandian for inviting me as a resource person for this conference. Thank you, sir.
Thank you. Welcome.
In this talk, the title of the talk is K in each graph of commutative rings. Okay. In this talk, I am planning to discuss construction of various K uniform hypergraph from commutative ring. Okay. And my outline of my talk is K uniform K0 divisor hypergraph of commutative ring and K annihilating ideal hypergraph of commutative ring. Okay. Just introduction about K0 divisor hypergraph. The concept of zero divisor graph of commutative ring was first introduced by I. Beck in 1988. In 1999, D.F. Anderson and P.S. Livingston introduced and studied the zero divisor graph of commutative ring. Okay. In view of this zero divisor graph, Esclache and Rakim introduced the idea of K0 divisor hypergraph of commutative ring in 2007. In this paper, they extend the concept of zero divisor of commutative ring to K0 divisor of commutative ring. First of all, I discuss the properties of K0 divisor hypergraph. Definition of K0 divisors of R. K0 divisors of this definition is introduced by Esclache and Rahim in 2007. For positive integer k greater than or equal to 2, a non-zero non-units element x1 is said to be a K0 divisor in R if there exists k minus 1 distinct elements x1, x2, x3 up to xk different from x1 such that product of this k element is 0 and the product of any proper subset of x1 to xk is non-zero. Okay. K1 is a zero divisor in R if there exists k minus 1 distinct elements x2, x3 up to xk different from x1 such that their product is 0 and any product of elements of any proper subset of x1 to xk is non-zero. Okay. Here it is clear that every element of this set x2 up x3 up to xk is also a K0 divisor in R. Okay. X1 is a K0 divisor, then we get another distinct k minus 1 elements. That elements also a K0 divisors in R. Okay. Z of R comma K denotes the set of all K0 divisors in R. Z of R comma K denotes the and K is greater than or equal to 2. K is greater than or equal to 2. For example, every K0 divisor is a zero divisor. Okay. Every K0 divisor is a zero divisor, but converse is not true. For example, consider the ring Z4. 2 is a zero divisor. Okay. 2 is a zero divisor because 2 into 2 is 0. So 2 is a zero divisor, but 2 is not a 2 zero divisor. But 2 is not a 2 zero divisor because by definition x1 is a 2 zero divisor. There exists distinct x2 belongs to R such that x1 into x2 equal to 0. Here 2 into 2 is 0. So here 2 is not a 2-0 divisor. In general, 2 is not a k0 divisor for all k greater than or equal to 2. For this ring, Z2 of x by ideal generated by x square. Elements of this ring is 1 plus 0 plus ideal generated by x square, and 1 bar is nothing but 1 plus ideal generated by x square, and x bar is nothing but x plus ideal generated by x square, and 1 bar 1 plus x bar is nothing but 1 plus x plus ideal generated by x square. In this ring, x bar is a 0 divisor. X bar is a only non-zero 0 divisors in this ring. Okay, but this x bar is not a 2-0 divisor because x bar into x bar is 0 bar. Okay, so x bar is 0 divisor, but it is not a 2-0 divisors of this ring. Okay, in general, if k equal to 2, if k equal to 2, set of all 2-0 divisors of R. Set of all 2-0 divisors of R is nothing but set of all non-zero 0 divisors of R. Okay, Z of R star denotes the set of all non-zero 0 divisors of R. Okay, when R is not equal to Z4 and Z2 of x by ideal generated by x square. Okay, set of all 2-0 divisors of R is nothing but set of all 0 divisors, non-zero 0 divisors of R. Suppose Z of R comma K, Z of R comma K is non-empty, then it contains at least K0 divisors. Z of R comma K is non-empty, it contains at least K0 divisors in R. Okay, some examples of this ring. Consider the ring Z4 cross Z2 and Z2 of x by ideal generated by x square cross Z2. In this ring, Z of Z4 cross in Z4 cross Z2, non-zero 0 divisors are 1, 0, 2, 0, 3, 0, and 2, 1 and 0, 1. Okay. In this ring, 1, 0, x bar, 0, 1 plus x bar, 0, x bar, 1 and 0, 1. But 3-0 divisor is empty. Here, this ring contains no 3-0 divisor. So, Z of R comma 3 is empty. In general, Z of R comma K is empty for every K greater than or equal to 3. So, this ring has no K0 divisors for all K greater than or equal to 3. Consider the ring is Z2. Consider the ring Z2, Z8. Here, Z of R equal to Z8. Z of R star is nothing but 2, 4, 6. Okay. Here, 4 into 2 equal to 0 and 4 into 6 equal to 0. Okay. But 2 into 6 is not equal to 0 in Z8. Okay. Here, 2, 4, 6, 2, 4, 6 are 2-0 divisor. 2-0 divisors, but 2, 4, 6 are not 3-0 divisor. Okay, not 3-0 divisors. Okay, because product of 3 element is 0. 2 into 3, 2 into 4 into 6 equal to 0, but 2 into 4 equal to 0. Okay, it contradicts the definition of 3-0 divisor. It contradicts the definition of 3 divisor, and 6 into 4 also equal to 0. So this ring contains only 2 divisors. But so from this Z8 contains no 3 divisor in general. It contains no K0 divisors for all K greater than or equal to 3. So set of all K0 divisors of Z8 is empty for all K greater than or equal to 3. Consider the ring Z12 here. 1 minute. In R equal to Z12. Here 0 divisors of Z12 is 2, 3, 4, 6, 8, 9, 10. Okay. Non-zero, 0 divisors of Z12 is this. Okay. 3 0 divisors of this ring is here 2, 3, 2, 3, 6. Sorry. Here 2 into 3 into 10 is 0, but 2 into 3 is not equal to 0, and 2 into 10 is not equal to 0, and 3 into 10 is not equal to 0. Okay. So from this 2, 3, 10 are 3 0 divisor. 2, 3, 10 are 3 0 divisor, and 6 is not a 3 0 divisor. 6 is not a 3 0 divisor. Okay. Similarly, 4 is not a 3 0 divisor, and 8 is not a 3 0 divisor, and 3 is a 9 is a 3 0 divisor. 2 into 9 into 10 is equal to 0, but 2 into 9 is not equal to 0, and 9 into 10 is not equal to 0, and 2 into 10 is not equal to 0. So in this ring, 2, 3, 10, 9 are 3 0 divisors of Z12. Okay. Two, 3, 9 and 10 are 3 0 divisors of Z12. In consider the ring R equal to Z30, 2 into 3 here in this ring, multiple of 6 is not a 3 0 divisor, and multiple of 10 is not a 3 0 divisors, and multiple of 15 are not 0 divisor. Remainings are 3 0 divisor of this ring. The multiple of 6 and multiple of 10 and multiple of 15 are not a 3 0 divisor of this ring. Remaining 0 divisors are 3 0 divisors of this ring. 2, 3, 4, 5, 8, 9, 14, 16, 21, 22, 25, 26, 28, and 27. Okay. Suppose R is a product of two fields. R is a product of two fields. Then Z of R comma K is empty for all K greater than 2. R is product of two field. Z of R comma K is empty for all K greater than or equal to 3. In general, 0 divisor of this ring is nothing but set of all x comma 0 comma 0 comma y. Sorry, 0 comma y, where y belongs to F2 star. Suppose x comma 0 is a 3 0 divisors of R. Suppose x comma 0 is a 3 0 divisors of R. Then by definition, x comma 0 into a comma b and C comma D equal to 0, and for some A comma B and C comma D belongs to 0 divisors of R. Here, product of these two element is non-zero by definition of 3 zero divisors. So XA is not equal to 0. So XA into C, XA is not equal to 0, but XA C is 0. Okay, XA C is 0. In F1, F1 is a field, so it has no zero divisors. So XA is non-zero. XA into C is equal to 0. So in F1 has no zero divisor, so C equal to 0. Okay, so C becomes 0. So C equal to 0. So X into 0, X comma 0 and 0 comma D, product of X comma 0 and 0 comma D is 0. This contradicts the definition of 3 zero divisor. So this ring has no 3 zero divisor. In general, this ring has no K zero divisor for all K greater than 2. Okay. For some observation in local ring. Okay. Let R comma M be a local ring, which is not a field. A local ring is nothing but is a ring with unique maximal ideal. Okay, M is a unique maximal ideal in R. Okay, any field is a local ring, but converse is not true, because Z4 is a local ring but not a field. Okay, R comma M is a local ring which is not a field. Then the following holds. Suppose nilpotency of M is 2. Suppose nilpotency of M is 2, then Z of R comma K is empty for all K greater than 2. Okay. Nilpotency of M is 2 because nothing but product of any two elements in M is 0. Product of any two elements in M is 0. So Z of R comma is empty for all K greater than 2. Okay. Suppose nilpotency of M. Suppose nilpotency of M is 0. Nilpotency of M is T less than K. T less than K. Then Z of R comma K is 0. Empty. Z of R comma K is empty. Nilpotency of M is T. That is product of any T elements of M is 0. Product of any T elements of M is 0. Okay. So here T less than K, from this product of any K elements of M also 0. Okay. Product of any K elements of M is also 0. So from this Z of R comma K is empty. Z of R comma K is empty. For any in general, in any local ring which is not a field, M is a annihilator of some non-zero element in R. Okay, for any local ring which is not a field, M is the annihilator of some non-zero element in R. Okay, so for any X belongs to M star, with the annihilator of X equal to M, with the annihilator of X equal to M, then this X not in Z of R comma K for all K greater than or equal to 3. Okay, for all K greater than or equal to 3. From this we observe that Z of R comma K is non-empty for some K less than T. For some K less than T, and nilpotency of M is M power T equal to 0. Okay. Z of R comma K is empty for some K less than T. T is the nilpotency of M. Consider the local ring R equal to Z power as Z P power N, where P is prime. P is prime and n is greater than or equal to 3. N is greater than or equal to 3 and R is not isomorphic to Z8 because Z8 has no 3-0 divisor. Okay. AD is set of all x belongs to R such that GCD of x and p power n is D. GCD of x and p power n is D. In general, is an associate class of D. It's an associate class of D. Okay. Where D is a divisors of n. Divisors of p power. For each divisor D of p power n, AD is nothing but associate class of R. Okay. Cardinality of AD is nothing but pi of n by d, where pi is an Euler pi functions. Okay. In this ring, set of all 3-0 divisors of R. Set of all 3-0 divisors of R is nothing but union I equal to 1 to n minus 2 a p power I. A p power I. Union of these associate classes. Okay. In general, Z of R comma K. Z of R comma K is Z of R comma K is nothing but I equal to 1 to n minus K plus 1 a p I. A p power I. Union of associate classes. In general, for any commutative Artinian local ring, any commutative Artinian local ring is a direct product of Artinian local rings. So here R is a direct product of Artinian local rings. Ri comma mi is a local ring with unique maximal ideal mi and n greater than or equal to 2. Here mi is not equal to 0 for any elements xi in Ri satisfying this property. Annihilator of xi is equal to mi, then the corresponding elements first n tuple here xi belongs to Ri, other entries are 0. This type of elements not in Z of R comma 3. This type of elements not in Z of R comma 3. For every xi belongs to mi with this property. I just proof of this statement. I skip this proof. Suppose mi is mi is equal to 0. Mi is 0. That is Ri is a field. Ri is a field. In this case, n tuple ith place is ui, remaining entries are 0. This type of elements not in Z of R comma 3. For all units ui in Ri. Here mi is 0, Ri is nothing but a field. Okay. So this type of elements is not in Z of R comma 3. A similar way, mi is 0 for all I. Then the ring is reduced ring. Then the ring is reduced ring. Reduced ring is nothing but it has no non-zero nilpotent element. Okay. So R is reduced and n greater than or equal to 3 because n equal to 2 for any Artinian reduced ring is a direct product of field. Okay. So if n equal to 2, R is a product of 2 field. By observation 1, Z of R comma 3 is empty. So we assume that n is greater than or equal to 3. So in this case, this type of elements not in Z of R comma 3. This type of elements not in Z of R comma 3. From the above discussion, R is reduced and n greater than or equal to 3. If k is less than n, then Z of R comma K. Z of R comma K is nothing but a union of AL, where AL varies from 1 to n minus K plus 1. Here AL is set of all n tuple. Exactly L components in X are 0. In the n tuple, exactly L component in the R 0. Okay. If K greater than n, when R is reduced and n greater than or equal to 3, K is greater than n, Z of R comma K is empty. Z of R comma K is empty. K is greater than n, then Z of R comma K is empty. Next, using this K0 divisor, Eslachi and Rahim defined introduced the concept of K0 divisor hypergraph. Okay. First, hypergraph is nothing but it's an ordered pair V comma E, where V is a non-empty set of vertices. V is a non-empty set of vertices. E is a collection of subsets of V. E is a collection of subsets of V. Okay. Suppose this hypergraph is K uniform. Cardinality of any edge is equal to K. Okay. Hypergraph is a ordered pair V comma E, where V is a non-empty set of vertices and E is a collection of subsets of V. Okay. This hypergraph is K uniform, then cardinality of S equal to K for all E belongs to, for all S belongs to V. For example, consider V equal to 1, 2, 3, 4. Consider V equal to 1, 2, 3, 4, and the edge set is first edge E1 equal to 1 comma E is a collection of subsets of V. Okay, so E1 equal to 1 comma 3, and E2 equal to 1, 3, 4, and E3 equal to 2 comma 4. Okay, so hypergraph is vertex set is 1, 2, 3, 4. Okay, E1 is equal to 1 comma 3, so is an first edge, and E2 equal to 1, 2, 3, 4. So this black 1, 3, 4 is a second edge, and 2, 4 is a third edge. It's a hypergraph with 4 vertices. Hypergraph with 4 vertices. So here we discuss the properties of K0 divisor hypergraph. Here R is a commutative ring with the identity Z of R comma K is set of all K0 divisors of R, and K greater than or equal to 2. Okay. Okay. K0 divisor hypergraph of R is denoted by HK of R is a hypergraph with vertex set is Z of R comma K. Z of R comma K for distinct elements x1, x2 up to xk belongs to Z of R comma K. x1 to xk is an edge of hypergraph HK of R if and only if product of this xi is equal to 0 and the product of any k minus 1 elements of x1 to xk is non-zero. Okay. K0 divisor hypergraph is a hypergraph with the vertex set is Z of R comma K. x1 to xk is an edge of hk of R if and only if product of xi is 0 and the product of any k minus 1 elements of x1 to xk is non-zero. Okay. This is the definition of K0 divisor hypergraph of R. For example, if k equal to 2, Z of R comma 2 is nothing but Z of R star. Okay. So H2 of R is nothing but 0 divisor graph of R. Okay. Here K equal to 2. k equal to 2, then set of all 2 zero divisors of R is nothing but set of all non-zero zero divisors of R. Then H2 of R is, that is 2 zero divisor hypergraph of R is isomorphic to zero divisor graph of R when R is not equal to Z4 or Z2 of X by ideal generated by X square, because these two rings has no 2 zero divisor. Okay, so every 2 zero divisor hypergraph is nothing but zero divisor graph. Okay. Consider the ring Z12. Z of R comma 3 is 2, 3, 9, 10, and edge set is 2, 3, 10 is an edge, because product of 3 elements is 0, and 2 into 3 is non-zero, and 2 into 10 is non-zero, 3 into 10 also non-zero. So it's an edge of H3 of R. And similarly, E2 also edge. Okay. So this H3 of R contains exactly 2 edges. So graph is H3 of Z12. H3 of E1 is 2, 10, 3. 2, 10, 3. And E2 is 2, 9, 10. So it's a 3 zero divisor hypergraph of Z12. Let R equal to Z2 cross Z2 cross Z2. Z of R comma 3. Z of R comma 3 is nothing but these 3 elements 1, 1, 0, 0, 1, 1, and 1, 0, 1. This this hypergraph contains exactly one edge. Okay, that is these 3 elements form an edge of H3 of R. Okay, so this hypergraph contains exactly one edges. Consider the ring Z2, Z3 cross Z2 cross Z2. Here Z of R comma 3. Z of R comma 3 is 1, 1, 0, 0, 1, 1, 1, 0, 1, and 2, 1, 0, 2, 0, 1. Edge set is V1, E1 is V1, V2, V3, and E2 is V4, V2, V3, and E3 equal to V1, V2, V4. So this hypergraph contains 4 edges. Okay. This hypergraph contains exactly 4 edges. Similarly, R is Z4 cross Z3. Z of R comma 3 contains exactly 4 elements 2 comma 1, 2 comma 2, 3 comma 0, and 1 comma 0. And this hypergraph contains exactly 2 edges only. Okay. This consider the ring Z30. Z of R comma 3 is nothing but this elements. In this hypergraph, edge of this hypergraph is set of all x comma y comma z such that x belongs to associate class of 2, y belongs to associate class of 3, and z belongs to associate class of 3. That is edge set contains exactly, each edge set contains exactly 3 elements, 1 element from A2, other element in other 2 elements from A3 and A5. So this hypergraph contains 64 edges. Okay, A2 is associate class of 2. So these are associate of 2, and A5 is 5 and 25. A3 is 3, 9, 21, 27. So number of edges in H3 of R is 64 edges. Okay. In this, the H3 of R is connected and the diameter is less than or equal to for with whenever x square is not equal to 0 for every 3 zero divisor x in R. This result is proved by Esclache and Rahim in 2007. Myself and my student Jimmy proved the following. R is a commutative Artinian non-local ring and Z of R comma 3 is non-empty. Then H3 of R is connected and diameter is less than or equal to 4. Diameter is less than or equal to 4. And the width of this hypergraph is either 2 or infinity. Width of a K0 divisor hypergraph. Hk of R is either 2 or infinity. And here we characterize the width of hypergraph is infinity if and only if R is isomorphic to these three rings. Okay. Suppose width is suppose K 3 less than K and K and N are equal, then width of A of R is infinity if and only if R is isomorphic to Z2 power N. In this case, Hk of R contains exactly one edge. Hk of R contains exactly one edge. So width of Hk of R is infinity. Next, some characterization of a regular hypergraph. Okay, R is a finite reduced ring and it contains at least 3 maximal ideal. Then Hk of R is regular if and only if each Fi is isomorphic to Fj for all I and j lies between 1 and n. Okay. R is a finite reduced ring which contains exactly at least 3 maximal ideal. Then Hn of R is regular if and only if Fi is isomorphic to Fj for all I, j lies between 1 and n. Let R equal to Z p power t. Z p power t, where t greater than or equal to 4. H3 of R is regular if and only if R is isomorphic to Z2 power 4. Z2 power 4. Next, completeness of Hk of R. When R is Zp power n and p is prime and k less than n and k less than n. K is less than or equal to n. K is less than or equal to n. Then Hk of R is complete if and only if n equal to k. If and only if n equal to k. And R is a commutative Artinian non-local ring. Then Hk of R, H3 of R is complete if and only if R is isomorphic to Z2 cross Z2 cross Z2. And next definition is ideally based K0 divisor hypergraph. Some introduction about this graph is in 2009 SP Redmond introduced the ideally based zero divisor graph and Esclache generalized the zero divisor graph to K0 divisor graph, K0 divisor hypergraph. Myself and my student Miss Dr. M. Subhasini introduced the new hypergraph called ideally based K0 divisor hypergraph of commutative ring. This paper is published in Algebra Colloquium in 2021. In this notion, we extend the concept of zero divisor graph, ideally based zero divisor graph, and K0 divisor hypergraph to that of ideal based K0 divisor hypergraph. This graph is one of the generalization of zero divisor graph, ideal based zero divisor graph, and K0 divisor hypergraph. In this graph, we discuss some basic properties of HIK of R. First definition of ideal based K0 definition of ideal based K0 divisor. Here R is a commutative ring and I is an ideal of R and K is any positive integer greater than or equal to 2. A non-zero non-unit element x1. A non-zero non-unit element x1 is ideal based K0 divisor. If there exists distinct non-zero K minus 1 distinct non-zero non-unit element x1, x2, x3 up to xk in R different from x1 such that product belongs to I. Product of xi is belongs to I and the product of any proper subset of x1 to xk is not in I. Okay. Here x1 is ideal based K0 divisor. There exists distinct non-zero non-in K minus 1 distinct non-zero non-units elements x2 to xk. Product is belongs to I and the product of any proper subset of this element is not in I. Okay. From this, any element in this set is an ideal based K0 divisor. Okay. Any element in this set is an ideal based K0 divisors in R. Okay. Zi of R comma K denotes the set of all ideal based K0 divisors of R. Set of all ideal based K0 divisors of R. Some remark about ideal based K0 divisors. First remark is R is a commutative ring and I be an ideal of R. Then if I equal to 0, I is 0 ideal, then Zi of R comma K. Zi of R comma K is nothing but Z of R comma K. Z of R is a ideal set of all ideal based K0 divisor is nothing but set of all K0 divisors in R. Okay. Suppose I is a prime ideal. I is a prime ideal. Zi of R comma K is empty for all K greater than or equal to 2. For all K greater than or equal to 2. Consider the ring R equal to Z4. I is ideal generated by 8. I is ideal generated by 8. Here 2 is a ideal based 30 divisor. 2 is ideal based 30 divisor. Since 2 into 6 into 10. 2 into 6 into 10 is belongs to I and the product of any two elements is not in I. Product of any proper subset of 2, 6, 10 is not in I. So 2 is a ideal based 30 divisor. So 6 also ideal based 30 divisor and 10 also ideal based 30 divisors in R. Okay. So ideal based 30 divisors of R is nothing but these elements 2, 3, 4, 6, 9, 10, 14, 15, 18, 20, 21, 22. Some proposition for a K greater than or equal to 2, set of all K ideal based K plus 10 divisors. Set of all ideal based K plus 10 divisor is lies in a set of all ideal based K0 divisors of R. Okay. Set of all next I is a K prime ideal. I is a K prime ideal of R. If and only if Zi of R comma K is empty. Zi of R comma K is empty. K prime ideal is nothing but the product of K elements belongs to I implies some of the element belongs to I. Okay. So Z of I is a K prime ideal of R if and only if Zi of R comma K is empty. So using this K ideal based K0 divisor, we define ideal based K0 divisor hypergraph. Okay. Ideal based K0 divisor K uniform hypergraph is denoted by Hi K, power K of R, whose vertex set is Zi of R comma K. X1 to Xk is an edge of this if and only if product of this belongs to I and product of elements of K, any K minus 1 subsets of this set is not in I. Okay. Ideally based K uniform hypergraph is a hypergraph with the vertex set Z of I comma Zi of R comma K. X1 to Xk is an edge of this graph if and only if product of Xi belongs to I and product of any K minus 1 elements of the set is not in I. Okay. Some basic properties of this graph. Let R be a finite commutative ring and I be an ideal of R and K greater than or equal to 2. Then I equal to 0. Then I equal to 0. Then I equal to 0. Then is Zi of R comma K is equal to Z of R comma K. So ideal based K0 divisor hypergraph is isomorphic to K0 divisor hypergraph. Okay. I is equal to 0. Then Zi of R comma K equal to Z of R comma K. So ideal based divisor isomorphic to K0 divisor hypergraph of R. Suppose I equal to 0. Suppose I equal to 0 and K equal to 2 and R is not isomorphic to this ring, then ideal based K0 divisor hypergraph is isomorphic to 0 divisor hypergraph. Isomorphic to 0 divisor graph. Okay. In this case, ideal based hypergraph K0 ideal based K0 divisor hypergraph is isomorphic to K0 divisor hypergraph. In this case, ideal based K0 divisor hypergraph is isomorphic to 0 divisor graph. Okay, and R is not equal to this. Suppose K equal to 2, then if K equal to 2, then ideal based K0 divisor hypergraph is isomorphic to ideal based graph. Ideal based 0 divisor graph. Ideal based 0 divisor graph. This graph is introduced by S.P. Redmond. Okay. Example of ideal based K0 divisor hypergraph. When R is isomorphic to Z16 and I equal to ideal generated by 8, then ideal based 30 divisors of R is nothing but 2, 6, 10, 14. The corresponding ideal based hypergraph is this. Okay. Some properties. R be a commutative ring and I be an ideal of R, proper ideal of R. And the following are true. I is a prime ideal of R, then I is a prime ideal, then Zi of R comma K is empty for all K greater than or equal to 2. So ideal based hypergraph is empty. Okay. I is K prime ideal, then Zi of R comma K is empty. So this graph is empty. Suppose R is a direct product of Artinian local rings and N is greater than or equal to 2. I equal to I is an ideal. I is an ideal. Here this place is MS and this place MT. Remainings are whole rings. It's an ideal of R. Okay. This ideal is an ideal of R. The corresponding hypergraph of this ideal is empty graph. Okay. R is a direct product of local rings. Any ideal in R is a product of ideals in Ris. Okay. Any ideal in Ri is a product of ideals in Ris. So we I consider this ideal I equal to this. Then the corresponding ideal based hypergraph is empty. Corresponding ideal based hypergraph is empty for all k greater than or equal to 3. And this graph is connected when x square not in I for all x square belongs to zi of r comma 3 and the diameter is less than or equal to 3. And some relation between ideal based k0 divisor hypergraph of R and k0 divisor hypergraph of R by I. Okay. This one is ideal based k0 divisor hypergraph. This one is this one is k0 divisor hypergraph of R by I, concentrating R by I. Okay. Let I be a non-zero proper ideal of R. X1 to xk belongs to R minus I. X1 to xk belongs to R minus I. If the coset x1 plus I, x2 plus I up to xk plus I. This elements belongs to R by I. It's an edge of k0 divisor hypergraph of R by I. Okay. X1 plus I up to xk plus I is an edge of 0 divisor hypergraph of R by I. Then x1 to xk is an edge of ideal based k0 divisor hypergraph. Okay. This cosets form an edge of hk of R by I. Then this element x1 to xk is an edge of hi ideal based k0 divisor hypergraph of R. And next one and reverse of this statement. X1 to xk is an edge of ideal based hypergraph. Xi plus I not equal to xj plus I for all I and j lies between I for all I not equal to j. Okay. Then x1 plus I up to x2 plus I and so on. Xk plus I is an edge of k0 divisor hypergraph of R by I. That is second one is a converse of this statement. Okay. Converse is true when xi plus I not equal to xj plus I for all I not equal to j. Okay. Next one is if ideal based k0 divisor hypergraph is complete, ideal based k0 divisor hypergraph is complete, and k0 divisor hypergraph of R by R is non-empty, then hk of R by I is complete. Okay. Here ideal based k0 divisor graph is ideal based k0 divisor hypergraph is complete, and this 0 divisor hypergraph of R by I is non-empty, then 0 divisor hypergraph of R by I is complete. Okay. Next definition is next graph is K annihilating ideal hypergraph of commutative ring. Okay, K annihilating ideal hypergraph of commutative ring. In 2011, Beppodi and Rocky have introduced and investigate the annihilating ideal graph of commutative ring. Here A star of R denotes the set of all annihilating ideals of R. A star of R denotes the set of all annihilating ideals of R. Annihilating ideal is nothing but annihilator of I1 is not equal to 0. Annihilator of I1 is not equal to 0, or there exists an ideal I2, non-zero ideal I2 of R such that product of I1 and I2 is 0. Okay. Annihilating ideal graph of R is a simple graph with the vertex that is A star of R. Two vertices I1 and I2 are adjacent if and only if product of I1 and I2 is 0. Okay, product of I1 and I2 is 0. In view of this definition, I extended the concept of annihilating ideal to K annihilating ideal of R. And we extend the concept of annihilating ideal graph to that of K annihilating ideal hypergraph. First, we define K annihilating ideal of R. I1 is a non-zero ideal of R. Is a K annihilating ideal if there exists K minus 1 distinct non-zero ideals I2, I3 up to Ik in R different from I1 such that product of this K ideal is 0 and the product of any proper subset of the set I1 to Ik is non-zero. Okay, so this I1 is K annihilating ideal. So every element of this set is K annihilating ideal of R. So every K annihilating ideal is a annihilating ideal, but converse is not true. For example, ideal generated by 2 is a annihilating ideal of Z4, but this ideal is not 2 annihilating ideal. Okay, this ideal is not 2 annihilating ideal. K annihilating ideal hypergraph of commutative ring. Here A of R comma K. A of R comma K denotes the set of all K annihilating ideal of R. And K greater than or equal to 2. The K annihilating ideal hypergraph of R is denoted by AGK of R. Say hypergraph with vertex set is A of R comma K. X1 to Xk is an edge of AGK of R. If and only if product of this IA is 0 and the product of any K minus 1 element of I1 to Ik is non-zero. Okay. Suppose R is an integral domain. Suppose R is an integral domain. R has no annihilating ideal. So A of R comma K is empty for all K greater than or equal to 2. So hence this corresponding graph is empty hypergraph. Okay. Example of K3 annihilating ideal hypergraph of this ring. Z16 cross Z12. These elements are 3 annihilating ideal of this ring. Okay. E1 and E2 are edge of the corresponding K3 annihilating ideal hypergraph. Example of this R is a direct product of Z2 cross Z2 cross Z2 and is a S equal to Z8 cross Z2. These two are two different rings. This ring is reduced ring. This ring is non-reduced ring. So these two rings are not isomorphic, but a corresponding 3 annihilating ideal graph is isomorphic. Corresponding 3 annihilating ideal graph is isomorphic. This ring and this graph is some properties of this graph. When I square is not equal to 0, I square is not equal to 0 for every 3 annihilating ideal of I in R. Then AG of R is connected and the diameter is less than or equal to 4. Okay. In zero divisor, in K0 divisor hypergraph, x square is 0, x square is not equal to 0 for all 3 zero divisor in R. Then H3 of R is connected and the diameter is less than or equal to 4. Here R is a Artinian reduced string with maximal number of maximal ideal is n greater than or equal to 3. Then K annihilating ideal hypergraph is isomorphic to K0 divisor hypergraph of Z2 power n. Okay. Left side is K annihilating ideal hypergraph. Right side is K0 divisor hypergraph of Z2 power n. Okay. In this ring, these two graphs are isomorphic. And R is a product of field then growth is either 2 or infinity. Thank you. These are the friends. Thank you.
Thank you, sir. Very
Thank you.
nice presentation. Thank you. Thank you.
Thank you, sir.
May I now request Dr. S. Saranya, Assistant Professor of Mathematics, to propose vote of thanks.
Good afternoon, everyone. I am honored and very lucky to have the opportunity to propose the vote of thanks on this special occasion. I would like to thank our speaker, Dr. K. Silvakumar, Professor of Mathematics, MS University, Tirunelveli, for making this seminar a very meaningful and interesting, sir. Thank you very much, sir. Your very clear explanation, sir. Thank you very much. We hope you all have gained a very good knowledge and new ideas in algebraic number theory. Sorry, algebraic graph theory. Once again, I thank all for your cordial cooperation.
Thank you.
Thank you.
Thank you.
Thank you, sir.
Thank
Thank
you.
you so much.
Thank you, sir. Thank you. Thank you. So, KB, lunch break announce பண்றீங்களா?
So, dear fellow participants, let us take a small break. We will meet again at 2 o'clock. We'll meet in the same link.